I'm not so sure how the audio is going to be. I imagine it's going to be absolute fucking ass. Because, well, my headset cooked itself and it wasn't that good. So now I'm like using the mic on the actual laptop and it's like not exactly next to me. But, we're just going to send it regardless, right? Um, so to start with, I'm going to go over this sort of the arse end of this that we were doing. I was doing the other, well, it's been more than a week now, hasn't it? But I was doing last time. I've left in a bit of a sort of curveball in there, and it's going to kind of explain a little bit how these systems can be beaten. Um, so I've intentionally chosen a shit encryption method. Just by simply XORing it with just a random ass number and whatever, just sort of doing one simple thing has kind of caused a bit of a problem down the road when it comes to how secure this this system is. Now these are our original what we decoded or what we decrypted, and over here was our encryption. So these are all fully encrypted, and right away you can kind of see something interesting. All of these are exactly the same, which makes sense because we XORed it with the same number, and we XORed all of these, obviously, which are the same value. All these values are the same. So if we XOR this with the same key, it's gonna be the same. The result's gonna be the same as this one, and that's what we see here. The result is the same as this one, and the only parts that change with the last handful of values. And here, we go out 1, 2, 3, 4, 5, 6, etc. And if we look over here, 7, 6, 5, 4, 3, 2, 1, 0, F, E. So without even decrypting it, we can already take as a guess as to what this is going to be. And the encryption information is what we're going to send over air as well. So now at this point, we barely even have to deal with this. I mean, we can just straight feed this to it, and it'll accept it. 7, 4, 5, 6. What have we got? That'd be D. Okay, we've got a bunch of 8s, a bit of 9s. Yeah, that makes sense. That was counting. And then we've got this. So this one, now we've got our A, B, C, D, E, F, and you see here we've got a bit of a pattern here as well. 2, 3, 4, 5, 6, 7, A, B, C, D. Right? C. So already, without doing any decrypting, we've cracked the sequence because we used a poor security method. So now instead of having to decrypt the information into this and then reverse engineering it and working out what it's doing, we can just take this encrypted information and go, these are the same. Let's just use that. This goes 76543 D. That's a handful of 9s. Let's show that in there. We got this 2, 3, 4, 5, 6, 7, A, B, C, D. And I'm guessing E, F will be next. So what? It'll be F here and E here. And that will just be the same. And then we'll have 9s again. Yeah. Oh, yeah, that's right, yeah. Oh, look at that, 9. Yeah. So that'll be 9. That'll be 9. That'll be 9. B, A, B, C, say A, B, that'll be C, that'll be B, that'll be 1, 2, 3, or whatever the heck it was, that'll be this. Copy, paste that in there. And let's just make that look pretty again. And we can just keep going. We can just keep doing that. We don't even have to fuck around with the with decrypting it or anything. We can just straight away attack it directly because it was a terrible implementation. And this is the kind of stuff that we're going to see, or that you'll probably see a lot when reverse engineering rolling code sequences and then things like that. Unless they're super secure and everything's like properly encrypted, which there's a handful of modern stuff out there that is. There's also a handful of modern stuff out there that is no better than this. That is just absolutely, completely just. They may as well not even have tried. Right. So now that we've got that out of the way, we're going to kind of see something similar to this on reverse engineer my key. We're not going to see exactly this, but the general idea is going to show itself. They haven't implemented the security well enough, and the answer can just be seen, essentially. So I'm going to pull up URH here real quick, and I'm just going to record a signal. Oh, that's Spectrum Analyzer. I already know what frequency I'm on. No, that's a good idea as well. You can jump over to Spectrum Analyzer, right? And you can have a look at what frequency we're going to be on. Or you can open up SDR Sharp, which I should have somewhere here. There it is. So we might do the whole process here instead of just me giving away the bloody answer. Hopefully this should work. So I'll find my RTL SDR USB. Hopefully that works. So I'm 433 right now. I'm going to jump down to about 300 megahertz range real quick. So we can start all the way at the beginning because this is kind of where these things start at, is around 300 megahertz. So I'll hit the key and I didn't see anything, so let's try 315. That wasn't the key. I'll hit the key. I don't see anything. So let's try 433. And I wonder what that is. Oh, there's a little spike there as I just hit the key. Yeah, that seems to be it. So we'll go and start coming up a bit until we. So we align with it. 433.992. Well, it's a little bit off, but it's 433.92. Awesome. Alright, so we've figured out we're at 42392. Fantastic. So now we can come back to URH, and now we can record at 43392. I'll just hopefully my stuff works. Yeah, we're in, and there we go. Recorded the signal, so we'll save that as whatever the heck it wants to be called. Hit the X here, and it should just pop straight up. Right. Now, this is the binary interpretation of what URH is essentially assuming this is off the rip. It's guessed that we're using amplitude shift key, AM. It's guessed that our samples per signal is samples per symbol or whatever, samples or symbols is 1500 microseconds per bit. So if we zoom in just here and I highlight one of these bits here or one of these symbols, it says it's about 1500. So that looks correct, right? There's a little bit of a problem with that. If we zoom out and go to our over here and have a look at our, because we've got preamble there, because it's got as you can see, it's just all very uniform here, and then it gets into a bit of ununiforminess. That's our data. This is going to be our preamble. So we're just going to come in on this and find a short one. Here we go. Here's a little one, and we're going to measure that distance there, and that gives us about 750, and half of 1500 is 750. So it looks like it's grabbed these longer ones and assumed that was our unit. Um, that's about 1500 there. This is in fact 2 units. We want just a single unit of about 750, and what's good is 750 is half of 1500. If this one was even longer again, you could probably assume it was twice as long, because that's how it's going to work. Each um, you're going to have a sort of an accumulation of these units. So you'll have your unit of just the one, or you'll have two of those, which would be twice as long. You may have three, which would be 3 times as long. You have four times as long. So it's gonna work like that. And mostly what you find in these systems that it's gonna be um you're gonna have two values. You're gonna have a short value and you're gonna have a long value. And the short value will go into the long value X amount of times. So we've worked out now that this 750 is in fact our single unit. So now if we come back to the front here somewhere, if I can find it, and we highlight one of these, we can see, we'll highlight this one. We'll see it's now 2 units, two symbols, because we've got 750 and 750 again. It's two. So that's essentially the kind of that's basically like the clock of the signal. Essentially, is every 750 microseconds, it expects a new symbol or a new piece of data. Now another thing we can check is let's kind of double check that we are dealing with amplitude modulation. I mean, already we can see this does look like amplitude modulation because it's on, off, on, off, on, off. We can also go and have a look at the spectrogram as well and see that it's the same. It's on, off, on, off, on, off. You can even see the data. So it's a bit change our, make it look a little bit more apparent. It's a bit hard to get it to do. You just sort of start messing around with these values until, whoa, that looks crazy. Until it starts to look good. And that does not look good. Oh, that looks good enough, right? Yeah, it looks garbage, isn't it? But we can sort of see that we're dealing with amplitude modulation. It's on and it's off, it's on, it's off, it's on, it's off, it's on, it's off. You also see there's a little bit of sway in this signal too, which is kind of cool. A little bit of sway in frequency there, which is pretty common for these. They're very cheaply made devices. They're low power. Yeah, that's pretty cool. Anyway, we can come back now to the go over to the demodulated view. No, let's turn that. Oh my god, just turn that down. And now what we want to do is we want to make sure this interpretation here is actually correct. So we want to sort of start checking. So way I can bring that into a bit more of a sensical. So I'll check this. Should be a single sample of one, a high. Should go low. Should go high, low, high, twice. Is that 2 ones there? Yep. So check another spot. That's a low, high, low, 2 highs, 1 low, 1 high. Yeah, so I can make an assessment now that the interpretation down here actually got it correct. If it hasn't, you can grab this line here. Oh my god. grab this line here and you can move it up and down, and anything in this pink area will be a 1, and anything in this green area will be a 0. So as you can see, when it's high, we're over here in the pink, and when we're low, we're over here in the green. So these spots here are triggering as 1s, and these spots here are triggering as 0s. And that's how it's able to demodulate into binary. So I'm just going to grab our binary here, and I'm going to throw it over into a text document. And we're going to start pulling this apart. It's a good rule of thumb to pull it apart sort of yourself, or at least just so you can sort of understand what's going on a little bit. Obviously you can do it all in URH, but URH is going to make some mistakes, and you're going to chase your tail on them a little bit. So it's good to have a look at the signal yourself first. Right, before we dive into this, I'm not sure if I've gone over this yet, but there are different forms of encoding. Now, for example, we can have the value of 3, and that's in binary. That's going to look like this. It's going to look like this. Now that's just clear, straight up binary. And look, we can already see right here. There's a 3. So is that it? Do we know that's 3? Well, not quite yet. There's another form of encoding, like a sort of pulse width modulation encoding. We'll just call this sort of just clear encoding. A pulse width modulation for 3 would look like, say, it would be a short high and a long low, and then we'll say that's our 0. That represents a 0. So another 0 there, and a 1 we'll say is a long high and a short low for 1. And this is what 3 would look like if it were pulse width modulated encoding. Now this isn't the same as encryption. They do this because of to sort of make sure that the signal is received. So this isn't a sort of an encryption or any kind of security kind of thing. This is just a simple sort of encoding structure to ensure that the data is getting across correctly. There's also Manchester encoding. Manchester encoding is a 1-0 for a 1 or a 0-1 for a 0. So for 3, we would have 0. That's a 9. We would have 0-1, 0-1, 1-0, 1-0. It would be 3. I'm pretty sure Keylock uses some kind of pulse width modulation, or sort of I think this might actually be our PPM. This one here. It's I can't remember from memory, but I think it's so the 3 we would do 1-0-0, 1-0-0, 1-1-0, 1-1-0. Oh man, I'm hitting all the wrong buttons here. 0-0, 1-0-0, 1-1-0, 1-1-0, and it's essentially just taking this middle bit. That winds up being the sort of the logic bit. So what we're basically seeing here is, for pulse width modulation, to encode 4 bits, it actually uses 16 bits, essentially 16 symbols worth of data to encode that bit. So you can't really go taking things at face value, like going, yep, there's a 3. In some signals, some lower end signals, you absolutely can, but a lot of the time there's going to be a kind of encoding to that signal. And one of the most common ones, and probably the one you should always check for first, is Manchester encoding, because it's quick and easy to check. In Manchester encoding, we will never see 111 and we'll never see 000. And that is because we're only ever getting 01s or 10s. Now here you can see that we have 2 1s next to each other. That's fine. But to get 3 zeros next to each other, we would have to do 0 0 here. And that breaks the rule straight away. We only ever get 0 1s or 1 0s. and that works the same way around. For 3 ones, it would have to do 1 1, and that's not a valid Manchester bit either. It would have to be, obviously, we would see 1 0, and now we've only got 2 ones next to one another. Right, so now how do we apply that to what we've got here? How do we know what encoding we've got? Well, first of all, we said the best thing to do is to check if it's Manchester or not straight away. If it turns out to be Manchester, we can assume it's not going to be this, and then we know it's not going to be those either. For this clear encoding, it really, chances are it could look like Manchester, but it will break the rules somewhere. Okay, so let's look for a 1 0 or a 0 1. So we'll start here, so we'll piss that off. Actually, the first thing we should look for is that rule of threes. And here we never see that happen. We're only seeing twos. We're never seeing threes, except for the very beginning here, which could be noise or could be anything really. To save the suspense, this is actually a sort of a thing with my key. It kind of ramps up for a second, or transmits high, and then it gets into Manchester data, or whatever its data is. So yeah, we'll do the check. So we'll start with our first pair, Manchester pair, and straight away we find out that we discover that it's broken. We're getting 0 zeros, 1 1, 0 zeros, 1 1s. That's a problem. That's not Manchester data. So let's change our offset. Instead, we'll start this next pair here, this 0 1 pair instead. And we're starting to see that it does in fact look like it might actually be Manchester encoded data. So let's grab that, because I like to kind of keep everything working. And we see from, if we start from the 0, we get good Manchester data, so we can ignore these ones because they were just a bit of noise or whatever it was. Obviously, to save the suspense, this signal is Manchester encoded. But we can always go through and painstakingly check. Yeah, this is a slow process, but you should always at least probably try and do it on just one signal before you pull out the tools to go and do that for you. It's once you understand what the signal looks like, it's a lot easier to then go and use all the tools, because they sometimes get things wrong. They'll accidentally flip a bit or something weird will happen. But if you know what the signal's kind of supposed to do a little bit, then you can kind of push those tools and sort of tell them, hang on, you're doing this wrong. You should align from here and not there, etc. We're just going to keep jumping through this to check if our rule gets broken. Right now we're obviously assuming Manchester. I do have a USB script that will just jump through all these and press space and that for me, which I probably should use. But fuck it. Yeah, this is tedious stuff here, but kind of want to do it all in one massive go, because it can be a bit obnoxious sometimes when you're trying to sit down and learn about something, and then they just go, oh yeah, and the data does this and that, and then all of a sudden they jump to the next scene or whatever, and all the data is different. You're sort of stuck there thinking, well, hang on a minute, what did you do? How did it change? It can be a little bit difficult to follow. So when you see it happen, before your very eyes, it's so much easier to understand exactly what's going on, what we're changing, why we're changing it, um, why we're taking the steps that we're taking. Um, what else do I want to add? Nothing, apparently. So let's skip through this, and then I'm going to decode this afterwards, um, back into their into the actual logic bits. At the moment, these are just the, you shouldn't really think of them as the bits. These are just the symbols, the high and low durations, um, and then we decode them, like Manchester decode them or whatever, into the actual logic bits, which are the actual binary information that's transmitted. As you can see here, we're stopped short. But the way on-off keying works, really radio signal, well, on-off keying mostly, but at the very end, what you're going to see is a bunch of zeros because we're no longer transmitting. And in on-off keying, when you're not transmitting, that's a low, and that's basically zero or a zero symbol. So we can assume that we're just going to get a bunch of zeros at the end here because the key is no longer transmitting. So what I can do is just take away all but one, and it's sort of assume that, we had a zero there, which we did. It's just that zero got caught up with the rest of the silence, so we only ever saw transmission end, but there is actually a zero there. If we look over this data, we see that it is in fact appearing to be Manchester encoded, and when it looks like it's Manchester encoded, you can take a pretty wild guess and say that it is. Right, so we don't need these ones anymore because we know that's just rubbish. Well, I know that it's rubbish. There's no point really explaining why I know that's rubbish. Yeah, it just fucking is. It's actually right here. We've got these 3 ones here right at the beginning. Yeah, okay, right. So now what I want to do is highlight, Control H. What? That's weird. Usually... Oh, there we go. Control H. And I want to turn all the 0 ones into zeros. Replace all. I want to turn everything that's 1 0 into 1. Replace all. And I want to remove all the space. Replace all. And now what we have is our actual data that's transmitted. These are no longer the symbols. These are now our actual data bits, our logic bits. So we've gone from having all the individual symbols to now having the actual data that's transmitted over air. We've now Manchester decoded the data, and you can see immediately as well. This looks a heck of a lot different to all of this up here. That's because this here's our data, and like we saw back in URH, we have our preamble, which is just kind of the preamble is used to align the receiver to the clock, so that way it can jump onto that, get itself in tune, or get itself in beat, and then once it hits data, it knows that's a 1, and then if I wait X amount of time, I'm expecting another data bit, it'll see load, it'll go, that's it. So it's getting itself into the... And the reason it's a double is because a Manchester data is 2 symbols, so it needs to see both in that duration. So it wants to see low to high or high to low within that duration. So we'll come back here. So we're going to have to try and separate our preamble from our data. Now, a good way to do that is to find where the preamble breaks down. So as we can see, the preamble appears to just be 0, 1, 0, 1, 0, 1, 0, 1 over and over and over again. So we need to find a spot where that stops happening. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. See if we can find a spot where something breaks. And that will signify the end of our preamble and the start of our data. And this will be the same for just about every radio signal. Obviously, every preamble won't be exactly the same, but the fact that something changes as soon as we hit data is it is something that carries over through basically everything. Obviously, then because it would have to know when the preamble ends, so there would have to be a change for start of data. There would have to be something that would have to happen for it to know it's no longer in the preamble. Otherwise, the first few data bits, it would just go, oh yeah, we're still in preamble, and it would miss those first handful of data bits. I can show that a little closer. Oh, hang on a minute, here we are. Right here. So 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, that's the start of data. And if this happened to be a 0, 1 for start of data, well, it just looks like this one, so it would just assume oh, that's preamble as well. And it would just eat it up, and then we get shit data. So it's obviously got to do something different to let us know we're in data. So now we can just grab this. 56 bits is another thing you can look at. You go, oh yeah, we're at about a certain amount of bits. 56 is actually very unusual, but 56 is fine because if we jump over to the old calculator, we can divide it 56 by 4. So that's a good indication that we're on the money there, sort of divisible by 4. So we'll go ahead and we'll grab our data, and I'll just throw it over here. Now we can start pulling that apart, so we can start putting that into those 4s. And then go ahead and decode that. So 1011 is B, 0100 is 4, that's also 4. 0101 is 5 in hexadecimal. This is C in hexadecimal, that's C in hexadecimal. All zeros naturally is 0 in hexadecimal. That is D in hexadecimal, 0 in hexadecimal. That's 1 in hexadecimal, that's 8 in hexadecimal. This is 4 once again in hexadecimal, this is 8 in hexadecimal. 8 in hexadecimal, and this is, I believe, 7 in hexadecimal. Right, so let's pull the spaces out of that. Right, so what does this tell us? It doesn't tell us a damn thing, to be quite honest. In order to get any usable information from this, we're going to have to do it again. So we're going to have to come back in here and we're going to have to grab another capture to compare it to. So hopefully this is going to be much easier this time around because we already know a lot about it. So hit stop, hit save that, piss that off. We know that this is supposed to be 750 because we worked that out before. That's a 6, 750. We can pretty much trust our data. Just have a quick look, see if our line is in the middle. Yeah, our line's in the middle. Alright, let's just trust that data immediately. Let's open up our text document again. Let's throw that in there. Manchester encode the data. Let's skip that. Let's piss off these ones because they worked out not mattering. So what we're seeing this one is is it 0, 1 we're looking for, or 1, 0? 0, 1 we're looking for, yeah. Which is here. So that's 0, that's 1 in Manchester. So let's just take it by 4s because we're still in Manchester encoded data. Actually, maybe it will be easier to, yeah. This is going to take too long. Let's work backwards. Screw it. Let's work backwards. So let's start about here. So 0, 1, 0, 1, 0, 1. This is a 1, 0, so let's separate that out and let's just keep looking through and see if anything funny happens. Wait, hang on. That's incorrect. 0, 1, 1, 0. Ah, there we go. We have 1, 0, 1, 0 next to each other. So this is 0, 1. We expect 1, 0 next. Now we're expecting 0, 1 and we don't get that, so I'm assuming that's our starter data there. We had, what was it, 56 bits, and this is Manchester encoded, so we're going to see 112 bits before. That doesn't look like the start of my data, so I must have another spot that breaks the rule further back. Actually, we do know there was another 0, don't we? Yeah, so 56 times 2 was 112, so let's just grab 112 bits then. Just do it like that. 111, 112. And what do we see? 0. I'm seeing some funny stuff happen here. This doesn't look quite right to me. So 1, 0, 1, 0. That's not something we want to we usually see. 0, 1. Yeah, so this is our Manchester 0, 1, 1, 0. There's another 1, 0 here. That looks like our data. I've got 113 bits here for some bizarre reason. Let's just grab it anyway. And throw it over here. Now, I'm going to have to Manchester decode this data. Oh my god, stop doing that, man. I'm going to have to step through this, separate it all out. I accidentally keep erasing it, so I have to press Control Z. If I double click and hit space, it erases it. Control Z brings it back. Oh, okay. That makes sense. I didn't need that extra 0. Because obviously there's not going to be a 1 here because it would be still transmitting. So in this case, I don't need the 0 there. Alright, Control H. We turn these into 1s. Replace all. 0, 1 becomes 0. Replace all, and then any spaces become empty. Replace all. Break them up into 4s. And we'll bring this back over to our other text document in a second. So break them up and copy them and bring them back here, was it? Yeah, let's bring it back here. And let's have a look at what this one is. So this is a caps on, no? This is a B. This is a 4. This is a 4. This is a 5. So you can already see what's going on. This is a C. This is a C. This is an O. Backspace. O. This is a D. This is an O. This is a 1. This is an 8. This is a 5. 8. And another 8. So we can pull out the all the spaces here as well. And start comparing some things, and some things have already shown themselves here as well. So I'll copy this one as our first one and just paste it here. This is our second one, and just paste it just there. So this is signal 1. What the heck? Signal 1. Let's do this so I don't get the ones mixed up. And now signal 2. And immediately we see some similarities. All the way to here is all the same. There's only 3 bits that are 3 nibbles that are different. This one goes from 4 to 5. These are both 8s, and this goes from 7 to 8. Maybe we can have a guess. So we can go guess 2. I guess the 3 is going to be. Let's just copy this. Show B, and our guess is going to be 6. 6, 8, 7, 8. Let's guess 9 for this one. And right, let's check. Let's check our work. So let's go record signal. Start. Start that. Save. Whatever. 750. Control C. Paste that in there. That ends with 2 1s. There's going to be a 0 there for our Manchester affair. 112. Copy. And to confirm that, that's 1010 right there. Look at that. So let's paste that in there. Let's go and quickly announce our data here. Oh my goodness, man. Yeah, this is the longest part, is this bit. So I suppose at the moment we're all kind of at the, pretty damn close. Looks like we've actually got it already. Quite quick, no? So, oh no, Control Z. No, 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 no. 0 1s. Become zeros. Okay, so spaces become empty.
What you doing, Papa?
Buckle. Let's go to curve that median.
Oh.
C C O D O 1 8 6 8 and 5. So let's subtract out our spaces there. Kind of brushed over it just before, but if we go back to here, you'd sort of say, "Oh shit, we've got it. We've nailed it. We smashed it out of the park." And this is why it's always good to check the next signal against what you believe. You sort of want to make an assumption and then check the data against that assumption. And as you can see, already signal 3. Whoops. Oh my god, I've got caps lock on. Signal 3 has almost followed that rule, but not quite. Something's happened. Now, in order for us to go and understand, well, what's happened here, we're going to have to capture more signals. So we'll have to go and do this again. Obviously, we're not going to go and do this again. We're going to start using the tools at our disposal now. But one quick thing is maybe it might be a good idea to go and double check that this is in fact a 5. So back here at our data, we need 8 bits because it's Manchester encoded. Let's just check that that is a 5. Yeah, 0101, that is a 5. So I've not made a mistake here. The data has in fact not done what we've expected it to do. We've guessed that we're going to see a 9 here, and we've in fact seen a 5. So it's completely broken our ideas. 4, 5, 6, 6. Yeah, that's what I guessed. Yeah, 6 was what I guessed. So we're getting 4, 5, 6. Let's take this guess. Chuck it over here. 6 is it 8 here, 7, 8, 5. Right, can we make the guess that this 4, 5, 6 continues 7, 8, 9? Because this 5 changed, but this 6 we got right. So can we assume something like signal or guess 4, can we assume something like B445 CC oh Jesus Christ, what the heck? B445 CCODO1 8 7 8 again, and then sort of question mark for this one where I'm sure. This can be our next guess. Right, well, let's start using some of the tools at our disposal now. So we'll jump over into URH, and we can see this analysis tab here. So let's jump over to that. We see all of our bits. And here we can see view data as bits, view data as hex, view data as ASCII. We want to view our data as hexadecimal. And in here decoding, we can see that we've got this differential Manchester encoding, Manchester 1, Manchester 2. I cannot remember which one is which. Try differential Manchester encoding, Manchester 2, I think. This one is. And then we go to our hexadecimal. We see a preamble, 5555555. What's this differential? Just 1. Okay, cool. Anyway. And then we get into our data 6 D11s. Okay, so we want to decode into hex. We've tried the different Manchesters, and we're not actually seeing anything that makes any sense here. But what is our preamble, by the way? We never really went over that. So if I come back to this and get rid of these, our preamble shown in 4 bits is actually 6 over and over again. So we should be expecting to see something like that, or at the very least it would drop the first 0 and we would just see C over and over again. Like so. So we're either going to see sort of C or 6 or something like that over and over again, and we're seeing 5 here, but we're also seeing this D, which is that little indiscrepancy that I have at the start of my data. So we're going to have to go and sort of tell this a little bit, a few more things. Well, what do we know about our signal? We know that we're always starting with this B. Seems to be something that continues to happen. So let's use that over in URH. We can go over to decoding, added decoding. I believe we want this edge trimmer. And let me check, what is Manchester 2 doing? Edge trimmer and invert. So we want now, we want the edge trimmer. I can never remember how to do this properly. I want the edge trimmer and I want the invert, but I also want to add cut before / after to add some other coding. I want to cut before, and let's cut before that B. So that B was 1 in Manchester, which is 1 0, then 0 Manchester, which is 0 1, and then 1 1, so 1 0 1 0. Um, let's save as deck. Let's just save it as deck. Okay, and let's back out of this. Let's choose our decoding deck. If I can get to do it. No, it hasn't quite worked, has it? Why hasn't it worked? Let's add the 4 in there. Which is 0 1 1 0 0 1 0 1. Should be an option for me to just hit save here, shouldn't it? Cut before and after. And then 0 0 1 1 0 1 0 0 1 1 0 0 1 0 1. That's B4. It should. Let's return to 0 deck and resistance. No, deck. Rex. I can never actually get this to work. That is how you're supposed to do it, and it's supposed to just work. But I've never been able to get it to work. Yeah, let's just go back to see if I can. Okay. I'm pretty sure I can just highlight a bunch here, and sometimes this is enough to fix it. Create label. Create label. No, I haven't done it. Oh man, how do I get this to? We changed this from bit to hex, and I can't remember how to do it. That's not it. Okay, what? No. Let's remove these for now. Delete. Delete. I can't think of it to work. Let's go back into um, the regular stuff and the bits. Let's go all the way to the end and we'll grab our 112 bits or whatever they are. There we go. How many columns have we grabbed? 121. 112. Let's make that the label. Not ready yet. We'll start here and make that our first label. So that's going to be our create label preamble. This is going to be our synchronization. And this here, we're going to make that our data. Because that little 1 thing, I don't know if it's important to the key. Well, actually, I know it's not important, but they maybe put it in there for a reason. I don't know. Maybe it is some little synchronization thing or something. Create label. Let's call this data. There should be a way that I can show this as hexadecimal. I cannot remember for the life of me. Yeah, I don't know. Not doing it for me. Yeah, now that I've kind of broken it up, let's see if changing to Manchester helps now. Yeah, no, it hasn't. Yeah, I can never remember how to get this to actually work for us. Maybe we have to start at Manchester and in bits. Let's try it like that. So 56 bits. What the heck? That's not right. No, that is right. It's right. Yeah. Okay. Let's go 56 bits here. Let's just grab everything in front of that. Call that bloody preamble and call the rest of that together. Sometimes doing this can get your H to align itself correctly, and when you change to hexadecimal, it will. There we go. There we go. It will spot what we're looking for. B445CC0D01848 and it's given us 4 for this one. We got 5. And that's because UIH likes to miss. And it's missing because of, we just go back to bits, you see it, yeah, it's kind of lost the 0 there. So it's just assuming that it's all zeros. So at the end it kind of gets a little bit funky. So that's why it's missed that. Hexadecimal. Hexadecimal. Yeah, there we go. Does that match what I see over here? 7, 8, 5. Yeah, so it's kind of missed at these last values. It's kind of missed these a little bit, but everything else it seems to have gotten right. Um, at the moment, we're not really that interested in this last value, really, because we wanted to sort of guess what's going on with this 5, 4, 6 stuff. And so let's look at that first. But now we can do the easy part. Now we can go over here and just record a signal. And we can just record a ton of key presses now. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's stop. Hit save on that. Put in our 750. And drag that over into our analysis. And then we can just make sure that's all correct there. There we go. Sometimes you have to take the encoding off and back on again for it to start picking it up. Yeah, now we really see this last value. It's always coming back as an 8 because it just sees a 1 and then a bunch of zeros. So it's kind of getting a bit lost there. So it's just giving us back 8 every single time. 4, 5, 6. Oh, yeah, no, 4, 5, 6 is fine. 4, 5, 6. And this is all 8. So now we're not actually getting the last value at all. Yes. Oh no, we're not getting it because I was zoomed over. But yeah, the values are a bit. They're actually not quite correct. Which I honestly don't really know how to get them to come back correct. I just always seem to have problems with the last value on UIH for whatever reason. And it's something that I kind of have to go ahead and do by hand. I'm pretty sure every second one it gets correct, and every one in the middle it doesn't, which is rather odd. And I think that's got to do with how the rolling works. It flips a bit gets flipped, and UIH prefers when it's flipped versus when it isn't, or something. I'm not really 100% sure why it does this, but it does. Yeah, let's jump into this. Hey, did my decoding work now? I was trying to just get rid of that because I don't need it because it never worked. Alright, well let's just grab everything. Actually, we don't need everything, do we? We just need this bit. So let's grab all that. And let's what were we guessing for this? Oh, we were guessing that we're going to jump to this 8, weren't we? So Control V. We know those first 3 we already did. So we'll piss them off. And let's get ourselves up to here. So everything starts appearing a bit more proper. Actually, let's do it the other way. Let's do it like this. Just piss all that off, align everything up. Separating from this 8 here. And I'm separating all of this too. And our guess was
7, 8 was our guess. 7, 8. And we were unsure about the CRC. Our next guess would be 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 0. You'd expect to see 1 next. These are all 8s. And this is, we're still unsure about what's going on here. Yeah, now we can sort of start chipping away at it, can't we? Alright. So let's start trying to understand the fields now, what fields we've got. So we're going to get rid of that. We don't need that. Just grab all of this and let's just copy it and bring it over into here. And let's start trying to understand some of these fields. We know this counts. We know these are all 8s. We're unsure what's going on here. This looks like some kind of static serial kind of information. So maybe we've got serial, count, and maybe some CRC kind of stuff. So maybe we can make our guess. Serial would be this. Our count would be this value here. And our CRC would be these 2 values here or something. Sort of start chipping away at this. Button number is something we've not checked, and I have been pressing just the same button. So let's actually see what happens when I press a different button. So let's go File, Record Signal. Let's go start that. I'll press it a couple of times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll stop and save that. And we're gonna come back over to our interpretation. 750. Yeah, there they all are. Analysis. And we'll just trigger some encoding on and off real quick. Oh, no invert. There we go. And we grabbed 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Control C. I did grab all, yep. Paste them in there. Oh, something changed. Which is what we're expecting. We're expecting something to change, aren't we? So let's grab our last 3 values real quick. We'll press a different button, so we're expecting something to change. This 1, 2, 8 stuff is still happening. We expected 0, 1, 2, 3, yeah, so that's still good. Oh, look at this. A bunch of 8s, and then all of a sudden we get a 9. Now it's staying as 9. So maybe that's something else we need to separate out too. Right. Alright, so what actually changed when we press a different button? This was already 9 when we're on the unlock or the lock. What was I pressing lock? The only thing that seems to have changed is this here. It's this 2 right here. It will already had changed to 9, so we can expect that. It looks like it's 8 a bunch of times and then it's 9 a bunch of times, so I have to find out what's going on there. And this looks like our button number here. So this stuff here is what we're trying to work out. I think we've got the button number under control here. That was pretty easy. Awesome. I'm trying to understand this stuff. So it's a bunch of 8s and that goes to 9. This is 4, 5, 6, 7, 8, 9, 0. Hang on, here's something. We have 8F and then 9, 0, 9, 1, 9, 2, 9, 3. Haha! That's got to be something. That's definitely something. Now we're cooking. So that's why that changed, that 9. That's why that changed. Okay, we're getting closer here. So now it looks like we might have a serial of this, because this is the same regardless of what button we've just pressed. And we've got a button. And I'll do our last one, that's 2. We're going to count, because that looks like it's TRU and T. That looks like it's definitely counting. What's going on? 9A. That's 91, I want 9A. And let's just assume, obviously, we're going to have some sort of CRC or checksum or something like that. You usually always do. 80A, 8A. So we're assuming that this here is going to be our checksum. It's the only thing that's left that we can't make sense of. And CRCs are usually the hardest thing to work out. Well, we also know that our CRC data is kind of wrong, don't we? Because at the end it's kind of wrong. So we have to actually work out what it's supposed to be and try and get UIH to do it correctly, which is a bit of a hassle. There's a quickish way of doing this. Let's go back to UIH. Let's turn off the encoding. Let's turn off the hex straight back to bits. Something funny's happened here. Okay. Oh no, hang on. There we go. Right. And what, it's 4-bit. Those last 4 bits are getting a bit funky. So let's grab, well, we've got to grab 8 because it's Manchester encoded. So let's grab all of that up to 8. So copy selection. And let's just paste that in here. Let's add the zeros where there should be zeros because it's just recording silence, so it's not going to bother with it. Let's do the old spacing of everything out. Unfortunately, this is kind of a long way, but it's gonna it's gonna verify that we do in fact get good data. It's just because it misses that last zero that it likes to confuse itself. It doesn't put it there, and sometimes it does choose to put the zero there. Other times it just goes silent, so I'm not going to deal with it. It's something that's really obnoxious. There probably is a way you can fix it and make it do it properly, but I have no idea how to get it to do it properly. Work out what all these values are supposed to be, and Control H. 0, 1 becomes 0, replace all, and 1, 0 becomes 1, replace all, remove all the spacing, Control H becomes nothing, replace all. Let's go through and work out what our values are here. That's E, 8, 5, I just know this because I've done it 100 times, 6, that's B, that's C, that's 9, that's A, that's F, that's 0, that's going to be D, that's going to be 7, that's 4, that's 2, that's 3, that's 4, that's 5, what the heck, 6, 7, 8, 9, A, B. Hey, there's a bit of a pattern emerging. Let's grab all that. Copy. Bring it back over here. So what we've got. This is supposed to be. Did I grab all of them? How many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so I just grabbed them all. So the E8, so this is supposed to be an E8, 8 was fine. 5, yeah, 5 was fine. 6BC9, is that it? 6BC9, 6BC9, oops, grabbed the wrong one, 6BC, yeah, see, so guess the second one's right, BC9, AFOD, so that's AFO, got that one right, D, it gets every second one correct, DOD, R74, I got that one right. Alright, so I just changed these ones, so this one's going to be confusing. What are we up to? 7, 4, so here. This is just 2, 3, 4, 5, okay, whatever. 2, 3, 4, there we go, 5, 6, 7, got that one right, 8, 9, got that one right, A, B. So it likes to get every second one right. I wonder why, like what difference there is. I should have had a look at that before, actually, what difference the difference between the value it gives me and what it actually winds up being. Because it might just be a tiny little change and we might be able to work it out. Because that one went from A to B. What the heck? Let's just copy this real quick. Paste it there. Let me have a look at what changed. Okay, it's not letting me go back any further than that. Damn. Well, I guess I can compare it against the results in your HDMI. What the shit? What is this? Go away. Manchester 2, bits, hexadecimal. Go back up. Let's grab our text document. Let's start at the bottom. So that went to B. And that 9. That was wrong. So 8 plus 1, 9. 6 plus 1, 7. Hang on. See if that happens the whole way through. 6. Ah, no, that's an E. 4 plus 1 is 5. That's 6A plus B. And then this is a C. B. A plus. Is this actually an E or is it 7? That's not E, that is 7. Look at that. I've cracked it. It is plus 1. Right, so now I can just trust all the data, and then every second I can just make it plus 1, plus 1, plus 1. And we've worked out that bloody CRC stuff. Awesome! Right, so what do we actually see here? I'm going to separate that out from when I change the button number. So when the button number changed, the counts still counted upwards. So that looks like that just keeps happening. So we can assume we have a serial count button and some CRC stuff, and we can assume the next one is going to be B445 CCODO. If it was an unlock or lock, it would be the command. 9A is going to go to 9B. We're still going to get 8 here. We're going to have to find out what's going on there. And this B, I have no idea, but 9. This was 2, 3, 4, 5, 6, 7, 8, 9, A, B. I probably just guessed that C, right? I mean, it's a bit weird that went to C, and then these ones are 7, 8. 7, 8, 5, 6, BC, 9A, FO, D7. Oh, there's some kind of inversion stuff happening here. There's some kind of inversion stuff happening here. Oh, of course it is. So what was that last one we're on? C? Or B? B. So let's just assume B. C, D, E, F, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 bit. Save that. Oh no. Yeah, I was gonna say, don't tell me weird stuff's happening. Oh man, I can never get that to 750. Analysis. Just turn that off. Turn it back on. I got about 20 that time. C, D, E, F, plus 16, yeah, so I'll go for that 20. How many rows? It's not telling me how many rows I've grabbed, it's only telling me how many columns I've grabbed. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 2, 3, 4, 5, 6, 8, 9. Alright, so I'm gonna grab from here. Control C. Back over here. This was a guess. So I'll just put a question mark next to it so I know that was a guess. Control V. It looks like sometimes we can guess this CRC, sometimes we can't. We did get it right. And then that next one is +1, so A, B, C, that'd be D, E's correct, that's F. The zero's right, that 4 would be 5. Yeah, so I have to jump back a fraction. Yeah, so we know the second one's wrong, so that's D. That E's going to go to F. That 4's going to go to 5. That 2 is going to go to 3. Must just be off by a bit. That 8 is going to be 9. That 6 is going to be 7. That C is going to be D. And that A is going to go to B. That 8 is actually going to go to 1. That E is going to go to F. Okay. And our guess was this, and we're correct. 9B, 8C, 8D, E, F, O. Hey, that's kind of cool. 2, 3, 4, 5, 6, 7, A, B, C, D, E, F. And that's what we expected. Like 4, and then I grabbed another 16. Because up here there's some kind of inversion. I'm wondering if it inversions back. Oh, what the hell? It's doing something really weird now. God, I hope that's correct. Yeah, that's correct. There's 3, 2. There's 2 zeros here. I think I've gotten these CRCs wrong. CRC stuff I think is wrong, so I'm going to have to go back into UIH, turn off the hexadecimal, turn off the encoding, and just grab the last 16 and actually work out what they are manually. So grab 8, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh god, it's so annoying. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. Paste that there. Put in my zeros. Do that on Manchester thing again. One zero zero zero. That's 8. That's 4. 0 0 1 1. That's 3. 0 0 1 0 is 2. 0 0 0 1 is 1. Yep. 1 0 0 0 is 8. Oh, that's 0 0 0 0. That's 0. That's 0 1 1. That's 7. 0 1 1 0 0 1 1 0 6. 0 1 0 1. That's A. 1 1 0 0 is C. 1 0 1 1 is D. 1 0 1 0 is A. 0 1 0 1 is 5. I've noticed something. Every 16, each value is only represented once. So when I seen A again, I was like, "What's going on?" I kind of noticed that back here when we got this. Maybe find it. There was a point where we went 2 3 4 5 6 7 8 9 A B C. That was a guess. C D E F. And that's E F. That's 16 there. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so that is 16. 5's there. Ah. Yeah, at the moment it's still a bit of a guess, but I'm pretty sure it's gonna. I'm pretty sure it kind of rings true. 1 0 0 1. That's 9. 1 0 0 0 0 0 0 0 0. Maybe it's not so true. One 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 is F, and 1 1 1 0 is B. 0 4 3 2 1. Yeah, I figured. 0 4 3 2 1. 8 7 6 5. 8 7 6 5 CBA9, CDA9, OFE, OFE. Right, that's better. Okay, so now what do I see? Two, three, four. What is going on? 5 is not represented twice, and I just typed that out. 043215 6 043210 043218. Son of a bitch. 8. There we go. Yep. 1, 2, 3, 4, 7, 8, 5, 6. AB, 9, FE. There's some kind of a pattern going on, and we saw it here too. 5, 6, CB, A9, OF. There's a bit of discrepancy here. But there's kind of a pattern emerges, and we saw 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 0. Something's going on. There's some kind of a pattern happening. And this is what I was talking about when I was mentioning when I mentioned that first thing we went over, that if the security's not that good, things start to emerge, and we're starting to see a pattern emerge here. So with enough captures, if I call it another, say, 100 captures or something like that, I would start to see that pattern begin to emerge. And indeed, that is what actually winds up happening. We do start to see this pattern emerge. I mean, I can go through and do it now and capture 1,500 signals, double check that we did get the CRC correct, and just absolutely take far too long to show that. But in fact, that is what's going on. We're seeing this kind of pattern start to emerge, and once I capture, say, 1,000 codes or something like that, or 100 codes or whatever, I can then start to piece that pattern together and start to see it. At the moment, we don't quite have enough data to start piecing that pattern together, but you can already see it start to emerge. Another thing I want to have a look at is this here. I noticed something 8F. It went to 9. So what happens if we go to 9F? Ah, here we are, 9F, it goes to A. Okay, now we're cooking. So scrap the B44 stuff. We can see here, we just keep going. No, I'm not going to do it like that. So we see AE, AF, well, actually, AF, the next one is going to go to BO. AF. Yeah, so let's have a look. Let's check that out. So file, record signal. So we only need to record another 2 signals to see that. So let's start. So that was F, whatever I said, this would be that BO. This might be B1. So let's stop there, save, save. Interpretation. 750. Analysis. hexadecimal, and interested coding. And we just did these last three. AF, there it is, AF, BO, B1. AF, BO, B1. I suppose now we need to start thinking, well, what happens when we get to FF? We're going to have to find that out. So what happens when this gets to B445 CCODO2 FF? What happens then? These are all 8 so far, so we've got 8 and then we've got a question mark CRC. So when we get to FF, does it go 0, 0? Does it just go straight back to 0, 0? Or does something else happen? That's what we need to work out. To get from AE to FF, we're going to have to go pretty damn far. That's about, it's like around 200, much no, about half of that. About 100 and something button presses from now. So we can go back to URH. What are we up to? We're up to A, B1, interpretation, record signal. So what did I say? Dude, what am I up to? Already fun. It's taking me 2 seconds. B1. B3, B4, B5, B6, 7, 8, 9, BA, B, C, D, E, F. And that would be C. This is D. So let's stop there. Save. Just check where we are up to. Let's go to interpretation again. Make sure that 750 is correct. So as you can see, it's just like real slow and tedious. Basically, we're just capturing tons and tons of signal. It's basically just sort of brooting the result, you know. So the more you capture, the more things start to show themselves. So here we are, we're up to D1. And that's what we did see. So where was B1 we're up to? B2, B3, B4, B5, B6, B7, B8, B9, BA, BB, BC, BD, BE, BF, CO, C1, C2, C3, C4, C5, C6, C7, C8, C9, CA, B, C, D, E, F, O, 1, 0, D1. Let's continue. D2, D3, D4, D5, D6, D7, D8, D9, DA, B, C, D, E, F, and then we're at E, E1, E2, E3, E4, E5, E6, E7, E8, E9, EA, B, C, D, E, so what's that, EF, so let's stop there, save. Back to interpretation, 750, analysis, Top of Manchester encoding on and off. EF, EE, ED, EC, EB, E8, E9. So now we want Fs now. So EF and next is FO. We call it signal. Start. Oh, stop. Fucked up. Can select my. There we go, start. So what am I up to? EF. That's FO, F1, F2, F3, F4, F5, F6, F7, F8, F9, FA, FB, FC, FD, FE, FF. Just stop and save that. Interpretation. 750. Analysis. Manchester. Turn that on and on. Look at that. That is it. FF, FB, FP, FC. So now we want to know what happens when we go past that. Because with hexadecimal, F is the highest value and 0 is the lowest. So we're not going to go to G, we're going to go all the way back around. So if it goes all the way back around, that means that there's only a count of about 250 and then it repeats. And then all we have to do is work out 250 of these CRC things, and we have all of them, right? So let's find out. Let's find out right now what happens. And start. So we'll record one more signal here. Just the one. We'll stop and we'll save. Go back to interpretation. 750. Interpretation, analysis, whatever. Manchester. Turn that off. Turn that back on. And let's go have a look. OO. What else do we see? FF. OO. 9. Look at that. That 8 is changed to a 9. So that's what happens. So now we know that these 8s actually mean something. I might scroll down way too far then. Okay, that pissed that off because that was some sign of gas. So we know once we get to B445 CCODO to FF, that's still an 8. This is unknown. And then we go B445 CCODO to OO, that 8 goes to a 9. And this is still unknown. So when we can assume, we can go through from FF9 to OOA, FFA to to OOB, OOB to FFB, and and then OOC, so FFC, OOD to FFD, and then OOBCDE to FFE, and then OOBCDEF to FFF. So we know nothing back here is going to change, because this is our button number stuff, and this seems to be count stuff, so maybe this other CRC value is something will happen to this, or maybe this is some kind of a counter thing as well. No, there's only one way to know, and that's really to capture a ton more information and actually see what's going on. But to save you the hassle, these last bits do that little pattern cycle thing that we're seeing here, this sort of inversion thing, and that just keeps happening until it eventually comes back around to the front, and then FFF goes to OOO, and we'll see the same CRC again. In this instance, I'm pretty sure for O2 with the that is actually 3 or something like that, and then it goes O2 O1. I think that might go to 4 or something, or it might 3 O. I think it's all O, and then O2 O1 O2 3 O. I think that might be a 4 or something. Well, it's actually a 1. In this instance, we need to work out how this CRC is actually calculated. There's a handful of different ways you can work out how the CRC is calculated. And you can just brute force that with a bunch of different, try it against a bunch of different known CRC algorithms and such. That'll work, and then you can eventually find the one that matches. As we know from the last video, that the stuff prepending the CRC dictates it. In this case, it's these count values and this button number that calculate out the CRC. And as we can see, this second one here, is obviously a counter as well, because we've got 8FF900. So realistically, we can put this 9 to the front, or put this 8 to the front, and we will literally get 8FF 900 901 902 903, and we can see that already here if we go 8FE 8 CFD. We'll go back to UIH. 8FD, 8FE, 8FF, 900. So when we decode, we just chuck that to the front. So what we've actually got here is a serial of that B445CCODO. Did I put I need to put 0. Then we've got the button, which is either O2, this is either 2 or 1. And then we've got the count, which take our last one here, AE8, E8, which when we flip those around for the decoding, we actually get 8AE. So really, it should be here
It's the original, that's the decoded. And then we have a CRC, which was, in this case, E. And there we go. That's basically all our fields now. We just need to try and understand what's going on with this CRC and how we calculate it. I can just go through and capture a ton more, and we can watch the CRC changes. Well, let's just have a look at what we've got so far. Should be plenty here, right? We've got, bloody, how many signals have we copied so far? I have no 125, so surely that's plenty, right? So we're going Manchester off. Don't want to invert anything. We're going to go to bits all the way to the end here. Cut that. Turn it back to Manchester. Turn it back off of Manchester. There we are. Let's grab the last 8 bits. Control C. Control V. Control V. So all we really care about now is this last CRC value. So now we can go ahead and try and crack what's going on here. Without having to do any sort of heavy math here, we're basically, a bee stick from being able to reverse engineer this. And already, because there's only 4 bits that we don't actually know at the end of this, at the very end, we can just advance the count, change the button to what we want, if we want to unlock or lock, and we can just brute force the last 4 bits. I mean, there's only, 16 possibilities? So we don't even have to crack this. We could just brute force the rest. We could just guess up to a point and then brute force the rest. So realistically, we've already done enough here to defeat a rolling code, completely defeat it, because we know all of this. We know it goes 9F, AO, A1, A2, A3, A4, A5. We know this is the button number. We know that once we get to FF, this jumps to 9. The only thing we don't know is these last 4 bits. 16 possibilities it could be. So we could try this next code. We could try, let's just copy this. Copy this. And we could try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We could, we want to try the next one, so we want to try this count 1. Oh man, this is clean. Try this count 1, so we just keep trying same count over and over again. And we can literally just brute force this last value starting at 0. We try 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. That's a 5, E and F. We could try every single one of them, and one of them is bound to hit on this particular one. So if we read this, we know that we've got B44, blah blah blah. We know the button number 2, so we know we can change that to 1 for the other button. we know we simply just advance these count parameters. If it's at FF, we obviously get to go to 9, 09. So we see this, it's 00, so we just go to 01, we leave the 9, and then we try and break every at the last bits. And we literally just turn those back into into their raw binary. B turns into 1011. We have to remember to Manchester encode it 1001, 1010, and then we have to remember to turn that into our timings. So each one was 750, so we can see here 750, and we see a minus because that's a low of 1500. See a positive of 1500. See a 750 negative. And we see a 750 positive, and we see a negative 750 as well. And that's all that that's that stuff that appears in the flipper. So we can literally turn that into the flipper raw. Oh my god, what's going on? Raw data. I think it's raw underscore data or something, isn't it? Raw. Where is the button I'm looking for? Oh, that wasn't it. And that raw data. Paste that into our .sub with our frequency information and all that stuff, and once we fill out the whole thing, then obviously we need to fill out the preamble, which was 0110, which is minus 750, and then 1500, then minus 750, and then it keeps going, 0110. So another minus 750, which can just be turned into a minus 1500, and then there's 1500, minus 1500, etc., etc. Put all our data in, get to the last 4 bits, put those in, and then do another raw data line after that. Do the same thing and put the next 4 bits, and then do that for all the signals, and then go out and play it back, and it'll hit. Or instead of doing another raw data, you could do another .sub file and then try each one at a time, and then you'll work out, say it's this one, and then you'll work out which one it was. Then you can advance the count. B445 CC OD 02 02 9, and then find out what the next CRC is by breeding it all over again. You could make a script or something like that that would go ahead and do that for you, maybe like a JavaScript or something, I don't know. Actually no, the JavaScript needs to have a .sub file that exists already. So you'd need something else, like maybe like a yardstick one or something like that to create a brute force script for it. But that it would all happen in 2 seconds. You would press it and it would go boop, it would find it, and then you would advance the count, get it again in a couple of seconds, advance the count, get it again in a couple of seconds, advance the count, get it again in a couple of seconds, and you just keep hitting it. Then you could change this 02 to a 01. Oh, sorry, this 2 to a 1, and then this, you could advance the count here and try a different button and brute force that. So, without doing any heavy math or anything really all that bloody special, we've got enough information here to completely get past the rolling code. We can't even predict it properly. We've just got it all the way down to a point where we can just brute force the last 4 bits because we understand everything else. But if we want to take it further and get it right the first time, we can go and reverse engineer these last 4 bits. Which is going to be a bit of a hassle here to go and work out what's going on in this pattern. But we've got about 125 odd captures here. And in one of them I changed the button number, and the button number is going to affect the outcome, isn't it? Damn it! I haven't even considered that. So it's going to be difficult to see. I have to get, like, say, 100 captures without changing the button number in order to see the pattern here. So I'm going to need about another 100 or so captures properly. Okay, let's do that then. There's no harm in doing that. Oh, good old YouTube. URH file. Let's record a signal. Let's just record 100 signals. Why the fuck not? Now start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. You're really asking a lot of it, but I do about 50 at a time here. Really asking quite a lot of it. Now we'll go back down to interpretation here, and we'll change that to 750. Look at that. And we'll go and have to record signal, and we'll do that again. We'll record 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. I'll stop that there. Save that. No, so that's it's probably 100. So it's 750 there. Let's go to analysis. Let's turn off all of these here, and we'll just grab our last two. 100 captures, 8 bits. Control C, Control V, show all those zeros. And yes, this is legitimately what I actually did the first time I did this. Like, I dead ass you went through and did this, except I didn't capture 100 codes. I actually captured 1,500. So I did what I just did then 15 times before I actually was able to to see it come back around. Yeah, it was fucking crazy. Um, and, yeah, there we go. That's cool. I wish there was a bit of an easier way to do this, but there isn't. Just have to break them all up. Oh, you bastard! What are you doing to me? Oh my god, this is gonna take. Probably this segment here is probably gonna take me like bloody 10 minutes or something there. Whoop! Really long time. I'm trying to think, is there another way I can handle it, or do I really have to do it the long way? It's actually something I want to have a look at as well, real quick. Sort of showcase. We can probably showcase that now, so I can turn all these back on. And we can go and do the old Manchester, and then hexadecimal. And look at that, we can actually see that number. So that's 00, OB, OF, 10. We can go through 2, 3, 4, 5, 6. Stopped at 6-4. Stopped at 900, 964 on the count there. It's quite cool. But the pattern remains. Or gone this far into it, even 100 signals later, and it still holds up. That's a good indication that we've cracked that and we understand it. So the more signals that you grab, the more it starts to things start to show themselves a little bit. Unless it's like a super difficultly crazy encrypted, unless they've done a really good job. But you can just capture a few signals of your own key or something like that, or of a garage or whatever you've got lying around, and just compare the two captures and just see what do they look like? Are they doing something that makes sense to me? If so, what happens if I go and capture some more? Does that still hold up? And you can go ahead and try and re-emulate that as well, and see if you can crack it. And it really is just sort of dead simple. You just like we've been doing here, literally just look at it and just see what it just have a look and see what it's doing. Not done anything not done anything special. I've not done any crazy math yet, and we're already to the point where I've already defeated a rolling code on a vehicle to the point where we can brute force it. And now we're working on that last 4-bit CRC to try and discover if we can get it right every single time, and we don't have to brute force anything then, do we? Alright, now we're cooking the fire. Now Control H. They're going to turn into ones, replace all. 0 ones are going to turn into zeros, replace all. Spaces are going to turn into empty spaces, replace all. Alright, and instead of going through each one of these, I'm just going to, I'm just going to Control H on that. 1010 is going to be A, replace all. And here I can see the next one is 1011. That is a B. Should put my caps lock on. It's a B, replace all. 1100. C, replace all. 1101 is D, replace all. 1110 is E, replace all. 1111 is F, replace all. You already see A, B, C, D, E, F, which is quite funny. 0000 is space is 0, replace all. 0001 is 1, replace all. 2 is 2. 3 is 3. 100, that's 4. Replace all. 101 is 5. Replace all. 0110. 6. Replace all. 0111 is 7. Replace all. And 1000 is 8. Replace all. I did 9. No, 9's here. 1001 is 9. Replace all. Let's just see if we got everything right. Okay, we did. Okay. A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7, 8. That's A again. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like there's something missing there. A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7, 8. You know what? This one here is probably a 9. See how I can have a look at that. I can. One, 0, 0, 1, which is a 9. Alright, so it looks like they break up into these chunks of 16. I don't see 7 twice there. see A again until here. Is there a double in this? There is. It's 9. Without knowing, what if the count has something to do with it? Because there's 16. Yeah, so it might have something to do with the count. So where are we? These last ones. So I've just grabbed these ones here. Trying to wrap my brain around this real quick. And then go to the top of the 100 and just capture it. This is 01. 01. Which is this one. Which makes this one 100. Two, 903, 904, 905. BC, D, BCDE, and this is A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or A, B, C, D, E, F, O, A, B, C, D, E, F, what the shit? O, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Doesn't appear to be any doubles in there. There's no doubles in there either. Oh yeah, now we're cooking. O, oops. I'm checking. O, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B, C, D, E, F. O, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, O, A, B, C, D, E, F, O, F. Done again. O, 1, 2, 3. O, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, A, O, 1, 2, 3, 4. See if that matches. Oh my god, it does. So what do we see? 9 A, B, C, D, E, F, 0, 1, 2, 3, 4, 5, 6, 7, 8. A, 9, C, B, E, D, O, F. We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or A, B, C, D. Wait, what's C, B? Oh yeah, B, C. So 9 A, B, C, D, E. 2, 1. This is 1, 2, so it looks like it inverts. Yeah, so it just inverts. So these two invert, then they invert again. And then in the next step, see 1, 2 is now here, so the place changes. So 2 invert, so each one inverts. And then the place inverts, so this one will invert to here. And then in the next one, it'll do the same thing. It'll invert another space. Oh well, this one will invert to here. And then the next one will invert this one. Will wind up here somewhere. Or down further, so it'll invert it. Flipsy-turvy. That's not letting me know. So it's just flipping the F, E, D, C, B, A, 9. So, and we know 9A, so based on this one, so that's 16. So 9AB, and then this will go, and then the next, so this 9A, so down here, F is going to start with, EF is going to start with this O. So we can do like a little table where we go 9, just give me a second, cut this. Paste. Check this out. A, B, C, D, E, F. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then do the columns. So for that A column, is A9, C, so let me just grab this. Put it here. I don't do like that. So it's A9C B E D OF2 143. Oops. 6587. No, maybe I did that wrong. But you can do this kind of, this grid kind of thing. And once you fill the grid out, you've got
So my
basically a little
headset
cheat
died.
sheet to work them all out.
My headset died. I went and hello. Hello. Hello.
I'll leave it there for now, and we'll get back to this in the next one.
Right, so we kind of stopped a bit abruptly there. This CRC stuff was like really kind of a bit difficult to wrap your head around and to get all the numbers to cooperate. One of the biggest problems is I can't copy and paste like downways, like just down, like just one line. It makes it so tedious to try and put all the values in and stuff, and it just becomes like rough as. But where were we? Back here, we kind of immediately noticed 9A, B, C, and then what was that 9? Yeah, you see it here, 9A, B, C, and then 9A, B, C. You would see D next, which is here, D, and you kind of get the same thing with like say A, 9, C, B. What was that? 9ACB. We'll probably see it in the data here somewhere. There it is, A9CB. And that's A9CB. So there's like a little bit of a kind of a grid sort of pattern that starts to emerge. And that's what I was doing here, is trying to build that grid out, and it just becomes absolute anarchy to try and sort it out. So I think, what am I on? This one here. So I'll grab this and I can just paste it there so I can see it all on the same page. So that's B, C, 9, A, D E O D E 3 4 1. I believe that means 3 4 1 3 4 1 2 7 8 5 2 7 8 and 5 6. And now I can grab the next one, which is this one here. Let me go back for a second. 900. Okay. Right. Just want to make sure this is the 900. So this is like the start of the nines. It's as we saw back here. So let's go to these nines, eights. We're starting here, are we? 900. 8. No. We're starting. Looks like we're starting here. 8900. Looks like we're starting right here, which is at a 00. So it's like at the start of that groupings of these nines. There should be like 256 of them, and that's what 16 by 16 makes 256. So we should get that chunk. So that's C B A 9 C B A 9 O F O F E D. I've kind of been out and about since, so I've pressed my key a couple of times, so when we do get back to recording that, I will have missed probably like 2 or 3. The best we can do is try and look at this grid when we build it out and try and like work out what actually goes where, which is usually actually quite easy to do, and you'll sort of see it. What was that? ED 43 4. It's a daisy. 4 3 2 1. I believe that was 4 3 2 1 8 7 6 5. 8 7 6 and 5. So we'll grab the next one now. Choose this one here. Copy that. Paste that there. So it's D, and as you can see, the D, like we're completely on the money. D, E, F, O, 9, O, 9, A, B, C. What is that? A, B, C, 5, 6, 7, 5, 6, 7, 8. 1, 2, 3. Is it 4? It is 4. Oops, that's got rid too much there. Grab this next one here as well. Copy that. Drag that over, Control V. So that was E, D, O, F, E, D, O, F, A, C. Jesus, I just messed up there. A, C. Backspace that. A. Oh man, I'm starting to get a bit. A, 9, C. I'm going to double check that. E, D, O, F. A9C, EDOF, A9C, E65, B65, 8, looks like 87, let me double check that, 87214, 7, 2, 1, 4, and 3. And then we'll come back to this. Okay, so we've only got a couple here. So we'll have to pick those up. F O D. God, my brain had a bit of a F O D E B E N B. Right. And I'll just come back here. I'm gonna have to try and work out what I'm up to here real quick. So these are the, I'm assuming the 9s, so that's 9 10s, 9 20s, 9 30s, 9 40s, 9 50s, 960, 961, 962, 963, 964. So that's going to be 964. So we can do that. Right, so now that I've got that, when I hit the key, I'll know how far it is to skip ahead. But already, just with this, is we can copy that real quick and just jump over here. And we can go and decide to build the data out ourselves, somewhat, if we want to. Let's start with a 0, we'll find one that starts with a 0 here. 0, F, E, D, B, C, whatever it is. And we'll see this A line, which is A, 9, C, all the way to 0. And the next is an F. And that's that O, O, F. So we know that that is going to be an F. So we can actually kind of start to build the data out. And now we have a crude way for predicting information now. So before we're on that sort of brute force idea, and now we're kind of almost at the point now where we can predict what's going to be the next value. And we could probably look at this one, which is going to be our next value. It will be that that 965 value. So what do we see? We need this E line, which is here. We're looking for 9C. And this is that E line. E9. And yeah, we can assume it's going to be that C. Or even, well, this is telling us, because all these lines match. This 9 to 8 is also down here, 9 to 8, down the bottom there. This picogram, well, that's the only one that we have fully mapped out right now, but we can pick this D to D down to 4. We can find this D line, and we can stretch it out to 4 because it's D, E, F, F, O, O, 9, obviously 9. Then we can go to A, B, C, 5, 6, 7, 8, 1, 2, 3, 4. So we'll go off this F line here. We find what we're looking for real quick. Okay, I might have to go the other way. So let's start with this E, because an E is a full line here. So let's find E here, and we'll go this way. So we've got EC, BC, so that's going to be B6, B6, 5, 8, B6, 5, 8, 7, 2, 1, is that 4, 3? Now we're going to look at this D line here. Here's a D line right there above it. And that's D. Let me just double check that D line, make sure I've got that. EDOF, EDOF, A9, CB6, 5, 8, 7. Yeah, okay, cool. So DEFAB, DE. So what am I looking for? This D line, DEF09, DEF09 AB, AB. So I'm starting from the C here. So C5, 6, 7, 8, 1, 2, 3, 4. Oh, that's a bit. And now we can look for the C line as well. So we'll look at the C to E, and we're going to start at this D. So we have D, 4, 3, backspace. What did I do? 4, 3. Where's my mouse? 4, 3. Yeah, it is 2, 1. Like I suspected. 2, 1. 8, 7, 6, 5. That's 8, 7, 6, 5. That was the C line, so now we look at this B. B to D, B to D, so now we want E. 3, 4, E, 3, 4, 1, 2. E, 3, 4, 1, 2. E, 3, 4, 1, 2, 7, 8. 7, 8. 5, 6. 5, 6. And we'll look for this last A line here, which is here. So it's A to F we got, A to F here. So we want A to F, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 6, 5, 6, 5, 8, 7. Alright, let's see if we can build out anything else now. I think I might have hit a bit of a stalemate here because I don't have full lines to base everything off. Here we go. 1, 2, 3, 4, 5, 6. There should be a 1, 2, 2, 3, 4, 5, 6. Now we could guess, couldn't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to the end, but we could be wrong. And this looks like it goes O, F, E, D, C, B, so that could be A, B, C, D, E, and then flip. It's kind of a bit of a guess there. So we'd probably be guessing most of these from sort of this point onwards, unless we can get some more captures. So we can compare that to where we were. Yeah, this is everything that we had. This was confirmed correct by the key, and this is kind of what we extrapolated on. Was this B? Did I guess that B or not? I did not guess that B. And from here, we're guessing C's next. Oh, well, I don't actually have that capture, unfortunately. Well, I'll skip past that one. I've been out. But we're pretty confident on it because we have an F line here, which goes to C. So we're just going to have to go and capture some more data, and I'm pretty sure a few of these, probably the next. So I went out maybe in the cart a few times, so I'm probably going to miss a handful, probably this many, something like that, but we're going to have a look. We are going to have to capture a handful more. So back to UIH. Now I was thinking, I might come back to that. We've got all the 2s here, and we're only grabbing from about here. So realistically, we probably should grab all these 8s as well, but just to keep things making sense, I just grab from the start of the 9s just for now, and we can maybe build the 8s after. there, as we kind of start building on these, it will start, the patterns will start to get more and more, we can make less assumptions because we're sort of seeing the data verify our guesses. So we're not going to have to do this for every single grouping, because that would be about what, 256 per, and then there'd be 16 times that. So that would be in that 4,000 range, that 4 something something, whatever it is, that magic number. Let me find it as a calculator. Calculator. 4,096. It would be. I'm not about to sit around and write out 4,096 of them. That's for sure. I should just be able to go down to record signal. Hopefully I haven't knocked about my SDR too much. Just bang out my antenna here, just to make sure everything's correct. I have measured that, haven't I? Yes, that was correct. It is frequency. Right. Let's just grab a ton more then. Okay, we're in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, and 46, 47, 48, 49. There we are. There's the last one. Stop that. Save it. Save it as whatever the heck it wants to be called. Do our good old 750 down here. And then come into analysis. Excellent. I'm now going to have to change from, no, I was turn the Manchester encoding off and put the Manchester encoding back on. There we go. Right, now I'm going to have to find out where I'm up to. So let's just turn all these off real quick so I can see where I'm up to. I'm up to 96C. And our last capture was 964. So that's 965, 967, 968. This is, what was that, 5, 6, 7, this is 8, this is 9, this is A, this is B, and this will be C right here. So there's a few we don't know. Cut back here, these ones we're getting with the key. So I'll come back to UIH. And what I want to do is, yeah, I want to turn off the credit bits, and I want to turn off the Manchester encoding as well. So I want to make sure that works. So I'll select Manchester 1 and just go back to 0 again. Come to the end, grab 8 bits. Oh, actually I'm going to grab so we've got 50 captures there. Look at that, it is. I did get all of them now, okay. Copy selection. Open up our notepad. Oops, open too many notepads. Paste. And we're going to join in our zeros. Because UIH doesn't like that last. It doesn't like that these end with just nothing. It doesn't append the 0. Append? I don't know. I think append. Yeah, it doesn't put the bloody 0 there, so it fails on the Manchester pair. It really doesn't like doing it for some some reason. There probably is a way to make it do it. I just don't know what it is. Now instead of turning these into Manchester pairs and then doing it, I'm gonna go about it the other way. So I'm just gonna Control H. I'm gonna turn 0, 1, 0, 1, 0, 1, 0, 1 into 0. Replace all. And I'm gonna turn 0, 1, 0, 1, 0, 1, 1, 0 into 1. Replace all. 0, 1, 0, 1, 1, 0, 0, 1. Oops, into 2. Replace all. And then 0, 1, 0, 1, 1, 0, 1, 0. Yeah, that was correct. 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 0 into 3. Replace all. 0, 1, 1, 0, 0, 1, 0, 1 into 4. 3, 4. Replace all. 5 is 0, 1, 1, 0, 0, 1, 1, 0. 5. Replace all. I literally just know this by heart now, guys. 0, 1, 1, 0, 1, 0, 0, 1 into 6. Replace all. 7 is 0, 1, 1, 0, 1, 0, 1, 0. Replace all. 8 is 1, 0, 0, 1, 0, 1, 0, 1. Replace all. 9 is 1, 0, 0, 1, 0, 1, 1, 0. 9. Replace all. And A is 1, 0, 0, 1, 1, 0, 0, 1. Is A. Replace all. B is 1, 0, 0, 1, 1, 0, 1, 0. B. Replace all. C is 1, 0, 1, 0, 0, 1, 0, 1. C. Replace all. D is 1, 0, 1, 0, 0, 1, 1, 0. Well, I messed that up. 1, 0, 1, 0, 0, 1, 1, 0. That is D. Replace all. E is 1, 0, 1, 0, 1, 0, 0, 1. It's E. That's an R. I want E. Replace all. And F is 1, 0, 1, 0, 1, 0, 1, 0. Replace all. Awesome. And these are from, what did I say this was from? Something C, 96C, was it? Yeah, I think it was 96C, so it's 96C. Just pen it down. 96C, let's double check. IUH. Just a 2. Good to do this twice if it likes to. There we go. Decode all 50 when that comes up. And hexadecimal. And that was 96C. Correct. Okay, good. Good. So this is C, D, E. So C, D, E, F. Huh. Do I take 0 now or 0? I can't remember if 0 start. 0 is at the start. 0 is at the start. Let's just grab this whole thing. So we'll copy that. And we'll drag it over to here, where we had our. We'll literally just fill it in. And so this was 964, wasn't it? It will tell me if we've done that. Yeah, 964 with B, which is here, 964. So that's 965, 966, 67, 6, 8, 6, 9, 6, A, 6B, and this is 6, C. So that's 3, 4, 1, and 2. So that's here. And that was on this F line. X2, 1, 4, 3. Let's check that against what we guessed on this F line. No, we never filled it in. Okay. And E was filled in here. Okay, yeah, so we never actually tried this F line here. Cool, I guess. Alright, this is going to be that next one. So I'm just going to scrap this and kind of, as we go, kind of fill it in. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So just enter that out, so I don't have to worry about it. So that's 0. F. Oh, what did we say for this one? What were we going to guess? Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So I can literally just do that backwards. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, A, B, C, D, E, F, O. The top there. Cool. So we can scrap that now. And the next one we're guessing was 1, 2, 3, 4, 5, 6, 7, A, B, C, D, E, F, O. Oop, that's a 2. O. This is double. That's 16 values and starts with 1. So yeah, that's 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and O. And if we just grab this right now and take it over to the one that we were guessing with, you can see that some of the values we've filled in are actually correct. They're actually on the money. That's the actual pattern. So we don't need that because that will lead us down a rabbit hole of absolute confusion. And we no longer need this too. Whoa, how much did I just delete? Control Z? 16 plus 16 is 32 plus 16 is like, I guess that's close to 50. Not if I'm doing the maths, yeah, okay. Wow, right. Well, guess I should have recorded a bit more than just 50, eh? So that's 2, 1, 4, 3, 6, God damn it, 6, 5, 8, 7, 5, and 8, and 7, 5, 8, 7, 5, 8, 7, A9, A9, C, A9, CB, BE, D. Oh, wow, stop short. You can also see other patterns emerge. 4, 4, 4, 4, 4, C, 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 4, 4, 4, 4. So we can probably guess that this question mark is going to be a C. And if we look at this E line, EDOF A9, A9 B65. Well, we filled out this E line now, haven't we? And this one we hadn't. Yeah, this one was what we guessed, and this one was based on the actual key. And we don't actually have that one because I missed it. Yeah. So we can, we're pretty confident that's going to be a C. But we'll keep building it out. So it looks like I'm going to need it's like 32. That's not 32, that's 64 plus 32. Is it? Yeah. So 64 plus 32 to finish this out. I'm going to need 96. So I'm going to need about another 100 recordings to finish this one off. And I'm going to finish this one off, and then hopefully we can start seeing some patterns when we build the 8s, or what we have of the 8s out, and hopefully we can apply that to that, and hopefully build everything out. But you can sort of tell at the moment, we've not had to do any sort of real math. We're just spotting a pattern and then just kind of putting the puzzle pieces together. Because they've chosen to do this through a form of obscurity, as opposed to doing it through any actual real encryption, or they've tried to hide what they're doing, but they've done it in a bit of a sort of, it's kind of like a cylindrical shift. So for instance, this 1 through O, it's reversed here, and then this one gets sort of reversed, but also each second one gets sort of flipped, so 1 2 becomes 2 1, 3 4, 4 4 3, and then on the next one there's sort of flipping of these 4 that will get flipped, and then those 4 will get flipped in the opposite direction, and then this one will flip about 8 of them. So it kind of just keeps flip, 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 and then it eventually comes all the way back around to the very start. Yes, which it will. As we can see immediately, we have an 8 here, and all the way on the other side, we have an 8 there. Chances are this 8 here is going to be 8 7 6 5 4 3 2 1 O F E D C B A 9. Chances are that's what's going to happen. We're going to have a 9 here, a 9 here, an 8 here, an 8 here. And these last few are going to be these first few, but backwards. And when we finish building it out, by actually seeing the data firsthand, it's most likely going to confirm what we've just discovered here. So for example, this 2 line here is here. So we've got 2 1 4 3 to 2 1 4 3 6 5 8 7 A 9 C B E D. 2 1 4 3, a couple of question marks. B E C D. B E D, sorry, rather. B E D. And look, there's that F O. We flip that, we get that O F, most likely. So you can see it happen right here in front of us, like in the flesh. Just wondering to myself, is it worth actually copying another 100 signals to show that without actually I should actually show that, shouldn't I? Instead of just, like, I know we can just guess it, but it's also good to show the proof, like, I guess. So I'll do that. Obviously we're gonna hit a point where it's just gonna be ridiculous trying to capture more and more signals. because like realistically, how many can we just go ahead and capture, especially in this video? Like when I was reverse engineering it myself, I could just sit down and just hang around for ages and, you know, record whatever the shit I wanted, right? And I wound up recording around about 1,500 signals, which is about 4,000 odd. That's like a quarter of them. It took me that long to find the pattern. Hoping here that I can, we can spot that pattern faster, especially now that I've got a bit of an idea on what I'm looking for. So I'll be able to sort of showcase a little bit better, hopefully. Otherwise this is going to be quite the long video. Again, just like the last one. So what did I say I wanted? I wanted about another 100 signals, so I guess we can just go ahead and do that, right? Just to show firsthand the actual data that we've made an assumption, and now or we've made a guess or an estimate of what's happening, and this is us double checking that, because as we've seen, when those 8s change to 9s, you know, we could have just made the guess that, oh, we just change these two values and it just goes back to 0 and we start again. That would have been a reasonable guess to make, but when we checked it, we found, oh, that 8 turns into a 9. So it's good to like check your guesses up against the real world data to sort of confirm it, or to say, oh, hang on a minute, I've also got to look at this. And then eventually you get to a point where you can go extrapolate all the way to the future, you know, check the next 2,000 codes if you want to, and just see that lines up and be like, yep, we're good. Which obviously I was able to do that with the car, just literally by sitting there and pressing it 1,000 times, and checking against it. I think I was even able to roll the data forwards a little bit faster than that, because there's a little bit of a window of what it accepts, so I kind of use that window to jump ahead of you and check. And then if it responded to the data, then I knew the data was correct. Let's record those. So this will be our first batch. Roll in. I just hit the key and it didn't record it. So we're going to have one missed again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and that's 50. Stop there, save that. I'll just do this first 50, and then pick up the next 50 after that. There we are. So it's 750 there. 750. 750. Analysis. Just gonna have to double check before I turn that on. What was my last one here? My last one was 99D. I just remember that 99D. This was one bit from the actual data. Okay. I'll turn that back on now. Manchester. Yes. So let's see. 99D, 99E, 99F. So I I did miss one. I want to turn it off. And I want to turn it to bits. Yeah, I didn't think so. And that was. So we're going to be starting from that 99F, because I've missed one. So this one's 99D, this one's 99E, and this one's going to be 99F. Oh, look at that, at the end of the column there. Yeah, so now we do the long bit again. Should make a bad USB script that that sets these up for me. But, making a bad USB script takes a bit of time. You kind of can't just write it willy-nilly. You've got to test it against the computer and write it at the same time and go back and have a look. It's like, oh, what can I press up to get there? You hit the keyboard and press up and press down and press left, press right and press backspace and then you go, alright, this is what I did, put that in the bad USB script, put in a little bit of delay, check it, I need more delay, I hit down once instead of twice, and you just, yeah, it's a bit of a hassle to write. Okay, right, Control H. Well, that's F, so let's replace all, work backwards, right? Why not? E is 10101001. E, replace all. It's okay, I don't know the alphabet backwards. 01010101 is 0. Replace all. 01010110 is 1. Replace all. 01011001 is come on you bastard, 2. Replace all. 01011010 is 3. Replace all. 01100101 is 4. Replace all. 01100110 is 5. Replace all. 01101001 is 6. 6. Replace all. 7 is 01101010. I think was that 2 or 3 then. 7. Replace all. 8 is 10010101. It's 8. Replace all. 9 is 10010110. 9. Replace all. A is 10011001. I'm not sure how I memorize these, by the way. Replace all. B is 10011010. B, replace all. C is 10100101. C, replace all. And D is 10100110. D, replace all. Awesome. So let's grab all these. Copy. Bring that back to our data. Yeah, before we jump ahead, let's talk about that. 0001, 0010, 0011, 0100, 0, 1, 0, 1, 0, 1, 1, 0. What's that? 6. So 7, 8, 9, A, B, C, D, E, and F. Now there is a correct way to read binary, and fuck knows if I can remember or even talk about it here. But essentially it's like counting. You know, you get to 10 and then you go to 11. This is the same, except 10 basically would just be, you know, here, and then 11 would be you jump over here and then you put the 0 down. Instead of putting 1, 1, you go 0. So you've started all zeros, then you get a 1, and then you've done the 0, you've done the 1, so now the 1 gets carried over and 0 goes there. And then you put 1, 1, and then you carry the 1, 0, 0, 1, carry that 1, so now we're on 1, 1, and so on and so forth. 1, 1, 1, 1, carry that 0. There's also another way you can look at it. There's places. This is I think the 1 place, the 2 place, the 4 place, and the 8 place. So that would be 8 plus 4 would be 12, plus 3 would be 12, 12 plus 3 is 15, plus 1 is 16, which is the 16 bits, is the other way to look at it. Now the way that I just straight up am able to rattle off the binaries 1 to F, or 0 to F, is, first of all, I've done this for like 2 years now, just this kind of crap, just playing with different radio signals, and I've picked up a few patterns. One of the most notable ones, or one of the first patterns I noticed, was, where are we? Was B here and D here. I was always getting them two confused. Because you'll notice, if I can just separate them out. God, I'm really bad at keyboards. Get back. Get over here. So end that down. Where's this? B and D was one of the first patterns I spotted. B is just D backwards, and D is B backwards. You've got 1, 1, 0, 1, or 1, 0, 1, 1. And B is the littler one, the smaller one, and D is the big one with 2 1s at the front, then 1, 0. That's how I remember B and D. C, I've seen 100 times, so I just know that as 1, 1, 0, 0. Just off the rip. E, I know is the big 7. So 7's 0s and a bunch of 1s. And then E is that backwards, bunch of 1s and a 0. Then we've got 4 is another pattern I spotted. 4 and 8. 4 is the little 8. It's just the 1s here, so it's 1, 0, 0 instead of 1, 0, 0, 0, 0. 9 and 6 are flipped as well, so this is 9. And then 6 is, where is 6? Here, backwards, so 6 and 9, which is quite good, because you've got 6, literally you've got 6, and you've got 9. They're upside down, they're flipsy-turvy, and so is the binary. 6 in binary is 0, 1, 1, 0, and 9 in binary is 1, 0, 0, 1. So they're flipsy-turvy. And I can just see that now and go, yeah, that's 9, that's 6, so just like reading. And obviously 1 is just a 1. 2 and 3 got me a little bit. 3 is 2 1s. I should do 2 first. So 2 is 1, 0, and 3 is 1, 1. And then obviously 4 is the little 8. And now 5 and 8 are the other ones. So we've got 5 and A, which A in decimal is 10, which is another good way of looking at it. It's 10, 10 for A, 1, 0, 1, 0. And 5 is the little 10, 0, 1, 0, 1. It's flipped. So that's how I remember all of those. Hopefully I went over every single one of them. 4, 5, 6, 7, 8, 9. Yeah, I did. Okay, sweet. That's how I remember them. And then, obviously, with Manchester encoding, I know that 1 is 1, 0, and 0 is 0, 1. So when I'm thinking 4, I just go 4 is 1, egghead 0, 1, 0, 0. So I just go 0, 1, 1, 0, 0, 1, 0, 1, which is that 0 and then 1, 0, 0. That's how I am able to rattle it off in binary as well. I can't just look at a Manchester encoded 4 and know it's a 4 immediately because my eyes are like, what the fuck is going on there? Like, you just can't make ends fucking. You just can't see what's what just by looking at it. It's too bloody numbery. But yeah, when it's just 4, you can really spot it. Alright, so let's get back to. Was it this? Yeah. And we said this one was a question mark. So this was 9D, which was our last one. 99E was the one I missed. And 99F, confirm, is the one we got. 99F. Yeah, confirm was the one we got. And that is this one here, which is, F. So we can scrap that now. Cool. And let's space out the next 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16-bit, 16 values. Starts with a 3. And what did we say before? This 3, 4, 1, 2, 3, 4, 1, 2. 3, 4, 1, 2, 8, 5, 6, B. 8, 5, 6, B, C, which was there. D, E, F, O. What? We changed it. D, E, B, C, D, E, F, O. B, C, 9. Ooh. Hey, maybe not. I'm looking at the right one, am I? Ah, I slipped off. BC9, yeah, BC9AFODE. Yeah, okay. Whoa, for a second now I thought things started breaking rules that I had previously thought were correct, but we had just discovered, which is, you did. Usually you don't want it to do that. You when it does that, you go, oh shit, I fucked up somewhere. Otherwise, when with the other case, when that number changed, the 8 to 9, we're like, oh, that's a surprise. That's cool. But in this instance, we'd be like, oh shit, because we've built out all this data based on that. So what did I say? 3, 4, 1, 3, 4, 1, 2, 7, 3, 4, 1, that's 2, 7, 3, 4, 1, 2, 7, 8, 5, and 6. You can see that stays, that 5, 8, 8, 5. That pattern just, it keeps emerging over and over and over. B, C, 9, B, C, 9, A, F, A, F, F, O, D, E, O, D, E. Nice. And yeah, literally, as you can see, it's, you know, ends with E, this one ends with E this way. They're literally just backwards. So you get sort of to the halfway point and it just goes, whoop, and it flips over. Because with those numbers changing the way they are in those cycles, it's kind of inevitable. It's the only kind of way it can happen because there's a finite amount of numbers. So when you flip them, you're eventually going to get back to the start. That's actually an algorithm. That's basically the very definition of an algorithm. If you have a finite, a sort of amount of things, I guess, and you pick the same move over and over and over again, they eventually come back to where they started. Is basically the definition of an algorithm. That's a really terrible way of explaining it. I know it from the Rubik's Cube. For example, if you move one side, because the cube is a finite object, you know, you can't move it infinitely on one side. It's a cube. It's a finite. It's got finite edges. You know, I make one move once, and then make that same move again, 3 times, 4 times. All I do is just do a full rotation of that one side. That comes back, and that's technically an algorithm. That's how that works. Obviously, if anyone actually is listening in cubes, then no algorithms is like a full R U R prime U R U 2 R prime. But if you repeat that, we all know it gets back to the start because the cube is finite, and we're doing the same operation to it, the same algorithm. That's this, you know, where it's a finite sort of amount of space, and we're doing the same process every time. We're eventually going to get back to where we started, and that's what we see here. That 9 8 9 8. We get back to where we started. Right. What am I up to? These fours. 3 4 3 2 1 2 1 4 3 2 1 8 7 8 7. I believe that next one was a 6, but that'd be, yep. And then 5 CBA CBA 9 9 O F 9 9 O F E D. Why am I saying E D? E D. I thought I already had a D in here. I did not. I did not. Number 16 was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Good. Piss those off. Yeah, you see these pockets. 1, 2, 3, 4, 5, 6, 7, 8. AB09, which are 09s like on the other side. Oh no, it is. It's on the same side. Oh yeah, because you can go through to F and then come to O. So and yeah, even here OFED. So these little pockets keep appearing because they're flipped. This 1, 2, 3, 4 should be over. Should be flipped around, and then this 5, 6, 7, 8 should be flipped around, and then you get A, B, C, D, E, F. And then you kind of got 1 to 5, or 1 to 8 on one side, and 8 to 9 on the other, but they're flipped. So if you flip them back around again, and then you would literally get back to this. Is 1, 2, 3, 4, 5, 6, 7. So that's all that they're doing. The DCRCs is just cylindrically rotating through them like that. 5, 6, 7, 8, 9, Nobody said 9. I said 9. 5, 6, 7, 8. 5, 6, 5, 6, 7, 8. 1, 2, 3, 4. Am I even that old for that song? I think that's actually before my time as well. D, E, 4, 4, D, E, F, 4, D, E, F, 09, A, B, 09, you egghead, 09, A, B, oh, C, do I have a 6 in here? I do, okay, that really bugged me. Oh, it's at the end. Dude. Oh, well that's that 6 anyway. And I ended here, well I actually ended here. So this is the end. Is 9 DO. Yeah. And this would be the DO line. This is the OO line. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. So we ended on 9 D O is what we ended on there. Hell yeah! I guess we can compare what we have here, copy, against what we had guessed over, what the heck, over here. So this was, we've verified that this was correct based on the actual data. So we'll look at, say, this line, which we definitely guessed, which was C, 5, 6, 7, 8, 1. I've still not filled that out, but yeah, it's there. And the other thing we observed was after this point, I believe we were looking at from here down, or was it here? We were looking at about from here. But these 1s to 0, here 1 to 0, it completely flipped. 1, 2, 3, 4, 5, yeah, could flip. And the 2 is flipped as well. That 2 ends at F, F-O-D-E, F, guess, O-D-E, which that was the one we missed, which was an O. We can also see it this way. So with this 7, 8, 5, 7, 8, 5, 6, 3, 4, 1, 2, F, 4, 1, 2, F, O, again, that's another confirmation that it's an O. And when we get to the end here, we can even come backwards from a 7 as well. So it's like completely gridlocked from all bloody directions. And that's that chunk, that 9 chunk there. So we're hopefully going to do the 8 as well, probably just as tediously as this, but I'm not going to copy so many. I'm probably just going to copy half of them or something like that, and then just build out the data myself. By following the rules we've found, and then we can compare 8 to 9 and see what's changed. And there might be an answer in there. The first row of the 8s might be the second row of the 9s or something like that, or some weird variation thing, and we can be able to work our way through the 8s, through the 7s, 6, 5, 4, 3, 2s, and on from the 9s, A, B, C, D, E, F, and we'll have everything. And then we can look at the locks as well, but we may only need, say, 16 of the locks or something to spot the pattern, and then go, yes, build the rest out, and off we go. But I'm gonna need obviously at least another 50 of these. Come on, I need 3 more lines. So it's 32 plus 16, 8, 3, 48. So yeah, another 50. Okay. 50 will do just dandy. And what was it? 9D0. I wrote that down. Good. Oops, I'll close my thing again. File. Actually, I like going to interpretation here first. I probably don't need to. I just do it in case something weird happens when it decodes from the second thing first or something. I don't know. Computers like to do funny things. Where are the keys? So let's start that. Wow, that was a bit weird. Just stop there and clear that. It's a bit funky. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 28, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, and stop. I'm going to say it. Might have been the neighbour's weather station, to be honest. 750 analysis. I'm going to turn off this last one. Scroll back up there a little bit. Just like double checking 100 times. 9 dear. Manchester off. Manchester on. There we are. And that's 9D1. So that's good. And we're finishing on AO2. Yeah, which sounds about right. Okay. So 9, sorry, what is that? 9D1. So I just type that in so I know what I'm up to. 9D1. That's going to be the first one of our codes here. I'm going to turn off the encoding again. I'm going to go to bits. I like to turn off the encoding as well because I don't like URH to do any interpretation right now. I want to do all of it, so that way I know I'm getting the correct data. I missed one. Copy selection. Okay, cool. Control V. Just Control A with backspace there, just to make sure that there's nothing else mixed in there. Because that's the last thing we need. Oh, and once again we're back at it. Oh, that's what that is. 0, 1, 0, 1, 0, 1, 0, 1. 0. Place on 0, 1, 0, 1. 0, 1, 0. 1. Place on 0, 1, 0, 1, 1, 0, 0, 1. It's 2. Place on 0, 1, 0, 1, 0, 0, 0. Replace all 0, 1, 1, 0, 0, 1, 0, 1. 3, 4. 5 is 0, 1, 1, 0, 0, 1, 1, 0. 5. Replace all. 6 is 0, 1, 1, 0, 1, 0, 0, 1. 6. Replace all. 7 is 0, 1, 1, 0, 1, 0, 1, 0. How many 1 zeros was that? 0, 1, 1, 0, 1, 0, 0. 7. Replace all. 8 is 0. Huh. Kind of inverse as well. 0, 1, 0, 1, 0, 1. 8. Replace all. 9 is 1, 0, 0, 1, 0, 1, 1, 0. So 9. Replace all. 1, 0, 0, 1, 1, 0. Oh god, my brain. 1, 0, 0, 1, 1, 0, 0, 1. Is A. Replace all. B is 1, 0, 0, 1, 1, 0, 1, 0. Bastard. B. Replace all. 1, 0, 1, 0, 0, 1, 0, 1. Is C. Bastard. Just do it. Replace all. D is 1, 0, 1, 0, 0, 1, 1, 0. D. Replace all. E is 1, 0, 1, 0, 1, 0, 0, 1. B. Replace all. And F is 1, 0, 1, 0, 1, 0, 1, 0. All ones. F. Replace all. Awesome. Those. Copy. Bring it back over. Come in this one. Which one would be? And we're after 91. Yeah, that's good. Double check that against our UIH, which we know to be correct. Oh! There you go. Just do something random. Just a 2. Yes. Bits. The hex. Which is 91. Which is, this is the D line. Because that's E, that's F. D1 is 5. Oh my god. Oh my god. Change my entire bloody seating arrangement. Fucking hell. I'm gonna keep the vape as well, why not? And that was which is here. Okay, so I don't need all 16 because I don't really need. Oh, right. Yeah, no, I think we're doing it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And what are we going to need this time? So 6 was, yeah, and that's a 5 next, which is, you can say U, 8, 7, 2, 1, 4, 3, 2, 1, is that 4, that's a 5, don't mess that up, 4, 3, 1, 4, 3, ED, ED, that's an R, ED, O, O, FA, A, 9, C, and B. Actually, I keep on talking about this thing again, this 6, 5, 5, 6. Because for this next line, we could probably have a pretty solid guess of what this is going to be. We're going to be an 8. And then we're going to get that 2, 1, 1, 2, but inversely. But that starts to break down. I remember when I was first looking at this, I was like 3, 2, 1, 4, 4, 1, 3, 2. I was seeing stuff like this here, these chunks, and then I'd sort of get to here and be like, well, what's next? And then like as you got deeper and deeper into it, you'd have to keep remembering how many times you've flipped and where you're up to in the sequence from end to end, and your head would just start to hurt. It would just be like really bloody strenuous to like remember it. So I could like predict the data for like maybe 16 or 32 sequences, button presses ahead of where I was. But the further out I got, the more I started to lose track, and things stopped making sense. I remember I had all these grids, like I've got this first grid, and I'm like looking at it all, and I'm just going, Jesus Christ, like where is the pattern? Where is the one rule that I can follow to work this out every single time? Because like as you branched further and further away from the starting point, it just got harder and harder and harder. And I mean, it's all good and to go from this 9 back to the 9 again. That's 256 values. And even that was a bit of a stretch to get to, but that's just the 9s. We're going to do the A's, the B's, the C's, and this pattern keeps going. Like these flips and inversions, they just keep happening. And it goes pretty far. And you know, between one group and another group further down, you know, you could look at 3 or 4 different groupings and go, yeah, I can see the pattern. And then you get to like the 5th one, and it would be that far gone from the original that you'd be like, oh, it's completely broken. Like the whole sequence is just stopped. It's changed. Something weird's completely happened here. It would just stop making sense. But then everything after that point would build up and start making sense, and then it would break and stop making sense again. It was so rough to try and cycle through and sort of see what was going on. What am I up to here? That's 587, 587 to that B. Yep, so I don't need this now. And that's 7, 8, 5, 8, 5, 6, 3, 4. That's 5, 7, 8, 5. What was it? 7, 8, 5, 6, 3, 4. Jesus. 6, 3. Well, I guess this is a sort of a good explanation of that. I mean, over here we've got 1, 2, 3, 4, 5, 6, 7, and then we've got 7, 8, 5, 6, 3, 4. Like, it just gets all kinds of confusing. Oops, 4, wasn't it? 1, 2, F, O. So we get the start, 1, 2, and then we get the end, F, backspace, F, O. But over here we've got the middle, and I'm guessing here we're going to get the front end bit before the middle. Oh yeah, D, D, E, B, backspace, B, you guess A, nope, C. So it could go either way. 9A, backspace, 9A. How do you break that up?
9A, this is enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. A9C, A9CBD, A9CBD, OF2, OF2, 143, 143, 6587. Yeah, okay, good. I got that right. Alright. Nice. And already, it's happened so quick. You capture 50 on, and you just do 2 lines, and it's bloody done. That's 8, obviously, at the top. So 7. And what did we predict? We were going to end with 9? Or it was going to be this flipped? 8, 7, 6, 8, 7, 6, wait, 8, 7, 6, 5, 4, 3, 2, 1, 8, 7, 6, 5, 4, 3, yeah, Jesus Christ, 2, 1, 3, 2, 1, OFED, OFED, CBA, CBA, oh, 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 what did I do? CBA, 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 CBA 9. 9. Dude, where's the 9 on my button? So to here, so this is 16. 1, 2, 3, 4, 5, 6, 7. And that's this backwards, so that's 9, A, B, C, D, E, F, O, and then 1 through 8. Perfect. Which would make this, this is 9FF. This would be A, O, O, A01, and this would be A02. So we shift that against the old A02, A00, A01, and the first one is C. So I got that right. I'd like to get every second one right. Yeah, see, and there's A at the bottom. But the middle one, it always gets that one wrong. Which is one of the ones that ends in a funny piece of data it doesn't like. But B, it's just the rule of thumb looks to be it's just A plus 1, so B. But I think I looked at that before just by grabbing all of these and trying to copy that rule over and just do every second one. But some of them came back a bit funny, I think, when I did that. So I'm having to do it the old, just grab the whole binary thing way. Just kind of makes this significantly slower than I would like, but it's kind of all I can do. So we can eradicate all that, so I don't need that anymore. What are we? I'll just hold on that. I think it's going to help me work out what I'm going to do with my question mark ones. There should be another question mark one in here somewhere. Right, well, let's grab all this, copy, and compare it against the data that we guessed. Control V. And as we can see, with this one and this one, they're all correct, and they're correct all the way up.
So we're completely right. And we're also correct with that inversion sequence as well. Now it goes 9 to 8, 9 to 8, 7 to A, 7 to A, 6 to B, 6 to B, C to 5, C to 5, and obviously all the in betweens all the same too. And it does it this way because we've mentioned this 7 here. We find the 7 here, and we're going to go to A. 7, 8, 6, 5. 7, 8, 6, 5. 3 was next. 7, 8, 6, 5, 3. 4, 1, 2, F, O, D, E, B, C, 9, A, or whatever the fuck it was. Yeah, you can literally just flipsy-turvy it. Right, so based off that, let's fill in our blanks. So that F to 2, F to 2, so that's an O. And now let's do our question marks. So this one is E, it's E to 3, 9 here. E, and we need to find 9. So that's C. You need to find another E somewhere, I bet. E, O, D, F, A, 9, C. And it's just the same every single direction. So C, F to C, F to C. Okay, so we don't have an answer there. F, here we go, F to C. The next is 9. That's a 9. Oh, actually, we can do it this way. We've got this F down. We can find this F up. So 9 is A. A. So F 9A, that's 7. And it's the same F 9A7, 8. Is that 8? There. F 9, 8, 7, 8, 5, 6, 5, and 6. That's a 7. F 8, 5, 6. 8, 5, 6. I'm saying this way, F 8, 5, 6. So we're going to have it here. We're going to have it this way. We're going to have it this way. It's going to be this way. And it's going to be this way. So a full crisscross. And there we go. That's our whole chunk of lines there. That's our pattern. And that pattern just happens absolutely everywhere. It goes into the 8s, into the 9s. It's just our start value is going to be different because when we go into 8s, we're not going to have 9 again. We're going to have maybe A or something next. Let me have a look back at our. Okay, so we're going to get C next. So C, B, A is what happens next. C, B, A. There it is immediately. C, B, A. And then we'll go to, so we can probably guess that our next is going to be C, B, A. Actually, we can just copy C, B, A. Copy. Control V. C, B, A, 9, and F, E, D. 4, 3, 2, 1, 8, 7, 6, 5. And that will be the same down this
down this way as well. So CBA, oops, in here. G4 header from B. Yeah, really annoying. I can't do it that way, but we have C, B, A, 9O, F, E, D. Why do I keep doing that? E, D, 4, 3, 2, 1, 8, 7, 6, 5. And you can just keep going around. So, 9 to 8, 9 to 8, 9 to 8, 9 to 8. So this would be 6, 7, backspace 7, 6, 7, 8, 1, 2, 3, 4, D, E, F, O, 9, A, B, C. And then you get the spaces here. But, you can kind of work your way through it. And now that we have you know what, it might be worth, let's just continue this based off this. And then we'll check a few points. We'll always record like 50 or so again, and we'll go through and just look at them and compare them to this graph. So just build this graph out completely based on what we learnt here. So that's 5. That would be 6 here. 6, 7, 8. What's that? 1. That's not a 1. That's a 1. So that's 8, 1, 2, 3. Son of a bitch. 4. 5. 6. There's 6. 7. 8. 6. Easy. Okay, this one I think I've messed up a little bit. Let me check. So 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 6, 7, 8 is right. 5, 6, 7, 8. 1, 2, 3, 4. Okay, yes, I did 1, 2, 3, 4. D, E, F, O, 9, A, B, and then C. And there we go. Now we've got our little square, which that's fun. Nice. So now we've got our square. Can we literally keep assuming that's how it's going to happen? CB, what do we say? CBA. We're borrowing from that. Can we, assume that every single line is going to do that same thing? That's just we're kind of starting from a different value.
I guess the best bet is to do at least 2 of them and capture about 30 odd signals and actually have a quick sticky beat. So this is B. So I need this B, a B line. Let's grab a B line from the start. Well, theoretically, I should be able to grab from C. Copy. And I should be able to go from 6 as well here. Copy. Oh, I should be able to. I should be able to do that for the whole thing. There we go through the 7. Oh, that's awesome. Yeah, nice. Control V. Next is 8. Let's find this 8 line. Maybe Control V. Dude, this is awesome. I'd be mad if it's this easy here. I don't even think I did this the first time around. Grab this one here. This one here. Three. Control B. 4. D. E. F. So this is going to be our guess. When we check the data, are either going to be completely wrong because the numbers shift circularly, they cycle in a different way, or we're going to be on the money. It'd be nice if we're on the money. Then we can have a look and see if we can find another rule for where the start value is, and from that we're laughing. Did copy the correct lines then, did I? Copy. Control B. 9. Copy. I'm pretty sure we can be confident the whatever numbers they are, the rules will still be the same for them. So the inverse thing, so the C to 5, whatever. So check maybe 6 to B, 6 to yeah. 9. So it's A line now. Copy that. Control B.
Yeah, that looks good. Okay, so this is the A's, and it's a guess. This one we know is right. So this is the 900s. That's the 800s and the other ones, right? So this is our guess. And we're basing it off CBA right here. So let's grab another shit ton, I suppose. And we'll check it against what we have. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, and stop. And save. So 50. Analysis. Total flat. Manchester. Missouri. West. All of them back to normal, thank you. Copy selection. Next. Oh man, I'm losing track of where I am. I'm gonna go back to URH. No, I want to turn these into this in the hex. And the first one here, AO3, which is coming back to units here. AO2, next is AO3. Awesome. So where are we now? This is the sheet that we're on right now. Copy. Let's just put that here so I know where I am. My guess now, this is my guess, CBA, which we have CBA already, don't we, from here, there is CBA. So we're expecting CBA, 90F, etc. Next, which is here.
0, 0, 1, 9, 0, 0, 0, 0, 1, 1, 1. I mean, look at that. We're basically, well, I mean, if the first one follows the rule, the rest of them have to follow the rule as well. So we're completely on the money there. So there could be a way that I can quickly write these out and then just quickly showcase that it's correct. I think so. But it's going to require me actually doing this stupid control H thing. Well, do that first. So, dude, something's going on with my mouse. 0, 1, 0, 1, 0, 1, 1, 0. 1. Place all. 0, 1, 0, 1, 1, 0, 0. Oh, fuck. 0, 1, 0, 1, 1, 0, 0, 1. 2. Place all. 0, 1, 0, 1, 1, 0, 1, 0. 3. Place all. 0, 1, 1, 0, 0, 1, 0, 1. 4. Place all. 0, 1, 1, 0, 0, 1, 1, 0. 5. Place all. Place all. 6 is 0, 1, 1, 0, 1, 0, 0, 1. 6. Place all. 7 is 0, 1, 1, 0, 1, 0. God, I always get that wrong. Okay, lose count. 0, 1, 1, 2, 3. 7. Place all. 8's basically that. The backwards is 1, 0. That's 0, 1, 0, 1, 0, 1. 8. Place all. 9 is 1, 0, 0, 1, 0, 1, 1, 0. It's 9. Place all. 10 is 1, 0, 0, 1, 1, 0, 0. It's A. Place all. B. 1, 0, 0, 1, 1, 0, 1, 0. B. Place all. B, C, 1, 0, 1, 0, 0, 1, 0. C, place all. D is 1, 0, 1, 0, 0, 1, 1, 0. D, place all. E is 1, 0, 1, 0, 1, 0, 0, 1. Replace all. And we do F at the end. So I'll grab all these. Stop that. If you copy that, bring it over here. Control B. Now let's grab those top few that we don't have. This CBA, which happens to be ABC. Go backwards. Control B. That D. Well, actually, let's back out, and a down on that. And now we can check if everything is in fact what we believe it to be. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 25. Yep. And then same here. 1, 2, 3, 4, 5, 6, 7, 8. Where that's it. You done goofed. Oh, no. This is our A1. I didn't goof. Don't worry, guys, I didn't goof. 2, 3, 4, 5, 6, 7, 8, 9, guess I'm forget to go a little bit slower. 2, 3, 4, 5, 6, 7, 8. I messed up. I made a D something I shouldn't have. Two, three, four, five, six, seven, 12, 13, 14, 15, 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, 3, 4, 5. So that's C, B, A, blah, 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 to 5. This is BC9AF, BC9AF, OD, E. I accidentally fucked up. FD, F. Yeah, this is supposed to be an E. This is supposed to be an E. And this here, A9, A9CB, E, E, and this 9ACB, 9ABCD, 9AB. Oh, fuck, where am I? 9ABCD. Okay, so that D is correct. But this E is one that I changed, so I'm going to have to verify if that's correct or not. Right, let's try this first E here. So this is AO1, AO2, AO3, AO4, AO5, AO6, AO7. Change to an E, so let's just double check that. This is AO7 here, which is my line 5. So that's 10, 0. Let's exit. Grab 8. Fuck. Oh. Yeah. Yeah. That's 1, 0, 1, 0. So that's the start of D, 0, 1, 1, 0. So that is in fact D. That is D. CBA. That's. This is A double O. 1, 2, 3, 4, 5, 6. Six is line 4. Manchester pair, that's a Manchester pair, that's a Manchester pair, that's a Manchester pair. And this is 1, 1, 1, 0. Yeah. Alright, so I messed up when I was changing the numbers there. I must have changed I must have done a 1 0 1 0 1 0 0 1 to D as opposed to doing to D as opposed to doing 1 0 1 0 1 0 0 1 to E. And then I also did 1 0 1 0 0 1 1 0 to a D, which is in fact a D. So I would have fucked up on the last one. I would have fucked up on the last one. So if I go to Control H, 1 0 0 fucking shit, Control H, I see this number, I've made it a D. Control V, which is in fact E. As we can see, subtract the end, and that is E. Yep, so I did fuck up. Okay, good. And we corrected these. A9CB, A9CBE. Yeah, so this follows the rules, and the next two follow the rules. BC9A, FODE, 3412, yeah. So actually, looks like I got that correct. I mean, we don't have to continue building that, collecting more data. I mean, we've already checked, something like this much of it, or a little bit more. We've checked probably something like this much of it, and it's all come out as correct. So I mean, obviously the first line was, that was pretty big guess because we only had CBA. But this one wound up being correct. This one wound up being correct, and I think a couple more after it wound up also being correct. That's a good indication that it is all correct, because obviously if these three are correct, that means these three are correct, these three are correct, and also these three will be correct, and that only leaves actually this three here, so that leaves about this area to here would be the only thing that we hadn't actually checked. I mean, that's half of it. Half of it might not be correct already. So yeah, we know we're on the money there. And that other half, that would just follow the rule, because every chunk follows the rule anyway. And we would have been able to build out that data, and it would have wound up being exactly the same as this. So we've done the nines by painstakingly doing it, and we've done the A's by just throwing them out there. This is also a 9, but we do have some of the 8s. We can do the 8s if we want. And then after we've done the 8s, we've got 8s, 9s, A's, we've got 3 sets then. We'll have 3 sets then, so let's just copy that and chuck it here, so we've got 2 good ones. We can pick up the 8s, and fill those out, and then we've got 3 out of 16, which is like, what? How many times does 3 go into 16? Probably not many as I think. So what's that? 16, 3 divided by 16 divided by 3? Yeah, 16 divided by 3, 5. Is that what I want? I don't know, my math isn't mathing, but that's like 1 15% or something of all of them done, or some fucking number, 25% or some fucking thing. There's about 5 times 4. Yeah, so like 20%. Roughly. Because 4 would be 25% of it. Bloody whole quarter. So we've just by doing this one and finding the kind of rule and grabbing sort of a couple of the next, right now we've done like 10% of it. So we can do the 8s. 8, 9A, maybe the B's after that. Just have a look at the B's real quick. And I will need the start value, don't I, to actually successfully do this correctly. Or will I? No, I actually won't. Yeah, and then that's 4 of them, so that'd be like 25% of it. And I think from there, we could probably just work out what the rest is. I mean, having that much of it. And is that... Bro, that can't be. Dude, that's about 1,000 recordings as well. And from there, that was pretty much what I had when I worked it out, when I discovered it. So we might not just having a repeat of that today. No. We do have the B's though. Not the B's, the 8s. So let's go grab our 8s. Let's just ish thing that and fix her up. Turn everything back on. Yeah, let's just see how many we've got just for the Lameos, right? I'm not going to be starting at the beginning of the 8s either, am I? Hexadecimal. And we have 1, 2, 425. Fantastic! Look at that. Yeah, we collected 425 signals. And yeah, this is straight up like how you go ahead with reverse engineering a rolling code system. Is you just fucking look at it. I mean, we've got all the ones from when we were pressing the button, and then here I've been doing the same button ever since. But you know, we've got that 891, 892, 893, and that just keeps going. 8B9, 8BA, 8BB, 9F, 2F, 930, 931, keep going, 98E, 98F, 990, 991, 9C, 9D, 9... Oh, we missed E. 99E. Remember, we missed E. I remember we missed E. Yeah, that's dope. That's funny. 8s. Where do the 8s start and finish? 8s are at line 124. And I only want to grab the 2s. Because the 1s are going to change our CRC value here. Because it's a CRC is calculated based on all the information, so we want to make sure our information remains the same. And we're just trying to work out the CRC in the CRC pattern, so we don't need to go and throw in lots to fuck us up. Yeah. question. Alright, what am I up to? So these are my first set of two. So from 14 to 124. So 14 to 124. I am grabbing the 14th one, aren't I? Yeah, yes, okay. 14 to 124. That's 124. That's 14 here. 124. Copy selection. Have I missed any? There is a chance I've actually a few key presses in amongst this. Yeah, I'll have that 681 in the row. Something. And I 8 did I miss anything in the 8s? I don't even think I did miss anything in the 8s. It was only in the 9s. They're fucking dinosaurs? Did you hear that?
Yes.
Right, I'm gonna need the counts. Yeah, I'm gonna need the count. I'm gonna need the count. I'm gonna need the count. Where is the counts? Manchester. Oh, come on. Oh, it's a cat. 14. Let's count 891. Page 91. And then, what was it, 124? Well, I don't have to guess, I can see it. And that is F, 8FF. Yeah, obviously. Missed that last one. I don't want to get confused here. And I'll just put it next to this one to finesse those. Fuck it, I suppose I'll just leave that there now that I've got a good starting point to jump back on. Yeet.
the home stretch here. So these were the 8s where we left off. I'm just gonna. I do have another copy of this. Yeah, okay, good. Just gonna get rid of that. Get rid of this. I didn't miss any of the 8s. No, I didn't. Right, well, let's go through and do this thing again. I can't remember if that was the D or the E anymore. 0 1 0 1 0 1 0 1 0 0 0 0 1 0 1 0 1 0 1 0 1 1 0 0 1 2 0 1 0 1 1 0 1 0 3 0 1 1 0 0 1 0 0 1 1 0 0 1 1 0 1 0 1 1 0 1 0 0 1 6 0 1 1 0 1 0 1 0 7 8 1 0 0 1 0 1 0 1 1 1 0 0 1 0 1 1 0 10 1 0 0 1 1 0 0 1. It's not 10, it's A. Goes back on A. 1 0 0 1 1 0 1 0 B. 1 0 1 0 0 1 0 1 for C. D is 1 0 1 0 0 1 1 0. E is 1 0 1 0 1 0 0 1. And F is 1 0 1 0 1 0 1 0. Right, so this 2 here was the 891th. Am I doing it this way or this way? I'm doing it downways, aren't I? Will it matter because it's a grid? Can't I just do it? Can I get away with doing it like this? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's place. 13, 14, that's 15. Yeah, because this one is 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 16. I'm going to put this one here like this. What's that look? I think I might be able to get away with this just being a grid like this. 3, 4, 2. Doesn't look like I'm gonna get away with that. But who do I see a minus 7s? This is 7, and this is probably. But this is not the. Maybe I won't. Yeah, let's do it. Actually, let's put that back. I kind of want to keep that for a second. Let's do it. Let's do it the way I've been doing it. Oh man, this sucks. So this one was the. This one's going to be a question mark because I don't know it. Because of 891. 891. And this is 8FA. There's going to be more than that. 891, 890, 2, 3, 4, 5, 6, 7, 8. This is going to be a 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, O. Like, that's easy. Right. And this is. So let's separate these out. God, I'm just bumping buttons. Oh, God, my head. 2. Is there a picture of Zero? I don't know what I've done there. Nothing, okay. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then there's a 6. Oh, that's more. 1, 2. Oh, yeah, that's going to be heaps here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, it's done. Right. God damn. Alright, so this is the 99. Yeah, so I'm like halfway through the cycle here. So I'm not gonna have the beginning. I'm gonna have one side, and from that we can build the rest out. Yes. Okay. Right. I'm on it. I know what we're doing. I know where we are. 4 goes here. I'd like to have a space. Oh, we'll work on that as we go. 4, 3, 2, 4, 3, 2, 1, 8, 7, 6, 5, C, B, A, 9, O, F, E, and 15. What's good is after we finish this one, everything's just going to start flowing after that. So this is the kind of the heavy brain stuff part. But I've kind of gone through it since and worked out what direction I want to take here to try and showcase this properly, and I've got a really good what I think is a really good way of actually showing everything here. So this video might actually be a bit shorter than the rest. So that's 3, 4, oops, 1, 2, 7, 8. Did I do that? So I think my brain's going a bit funny. Yeah, I did only backspace what I should have. 3, 4, 1, 2, 3, 4, 1, 2, 7, 8, 5, 6, BC, BC 9, C9, A, F, O, D, E, D, E. Okay. 6, 5, 8, 7, 2, up to 1, 4, 3, BD, OF, A9, CB, O, 5, 6, 7, 8, 1, 2, 3, 4, D, E, F, I assume. D, E, F, O, 9, A, B, C, B, C. 8, 7, 6, 5, 4, 3, the heck, 2, 1, O, F, E, D, 6, backspace, C, B, A, 1, and that's the last one there, 7, 8, 5, 6, 3, 8, 5, 7, 8, 5, 6, 3, 4, 4, 4, 1, 2, 2, F, O, D, those are the O, D, E, B, C, 9A. Fantastic. Okay. Copy that. Let's put it here. Is there any... Are there some similarities. Why didn't it work? 4143. I used 43 and used 41. I like that. Have I made something of a number that I shouldn't have made it? Because that breaks the rule. Oh no, stop. Stop, stop. That doesn't break the rule. This isn't the first 4. Because this is the 90th. It's the 9, 8. This is 890. This one right here. We've still got 880 back this way. So this is like a number halfway through the array or whatever. So this is a 4 from the start, because this is a 9 to the top yet. This is the bottom, and this is the far right side, the end. Yeah. So yeah, 4 3. That's correct. 4 3. Yeah. Okay. I haven't made any mistakes. So this kind of a thing did work. So I could have just done it like that. Okay. Copy. Throw it over with our others. Here we go. And put it right here. And let's go about filling this out. So that's what, this is the 90. No, I can just hit space to get there. Let's line it up like a regular human being. Alright. You watch now that I go to type everything in and everything will shift over. I fucking dodgy that up, and so yeah, I kind of did dodgy that up, but this is the idea. Right, there we have our empty box. So just need to enter here, and I'm going to put 800. 800s, 900s, 800s. Right, so I'm going to have to use this full line at the end here to do this. So it ends with 7, so this one here is A9C BEF BD big BEDOF 21 and then 4. So this is this. So make sure that's correct. A9C BEDO bed. Oh, bed by that. 2 1 4 3 2 6 5 8 7. Oops, 2 1 again. How did I have that? It was question mark and 0. The next this is 2. This was 9 1. So that was 0 1 2 3 4 5 6 7 8 9, and that was 9 1. Right, I'm on the money here. And now this is backwards. So this is 7, 7, 8, 5, 6, 7, 7, 8, 5, 6, 3, 4, 1, 2, F, and then O is here. So on that. And spacing that out. It should be out backwards, so it's 7, 8, 5, 6, 3, 4, 1, 2, F, O, D, E, B, C, 9, A, bracket. And this is A, 9, C, B, go away. A, 9, C, B, E, D, oh, come on, brain. A9, C, B, D, E, E, D, E, D, O, O, oh, yeah, O, F, 2, 1, 4, 2, 1, 4, 3, 1, 4, 3, 6, 6, 5, 5, 5, 5, 8, 7. 7 A9, C, B, E, D, O, F, 2, 1, 4, 3, 6, 8, 6, 5, yeah, 5, 8, 7, 7. Okay, yeah, cool. Got the money. Yeah, what's going on with my square here? It's all a bit squished. Well, the same rule applies now. And what we've noticed, which is, I don't think I noticed this last time, but every single set is always the same. It's just in a different place, which is quite interesting. This 8, 7, oh, it gets flipped to 7, 8, and down here, it's now over there, and it's flipped up to there. So it actually does the same thing as the individual numbers do as well. So that's quite cool. That means from here we can essentially follow that rule and build out all of them. All from, we don't have to copy any more signals now, we can just build them all out. So we should fill these in at the bare minimum. God, this is going to take a minute because it's downwards and not crosswards. Ugh. So it's 9 AB, yeah, see, 9 ABC, D, E, F, 9 ABC, D, E, F, it's all the same. So 9 A, B, C, D, E, F, 9 A, B, C, D, E, F, O, 1. This is 9. Come back here. 2, etc. Now on the C, B, A, C, B, A, C, B, A, 9, O, F, E, D, 4. Oh, why did I do it like that? That was being silly. Actually, no, it doesn't actually matter. No, I think. I want to make sure I got 4 right, and I didn't. Yeah, okay, and I didn't like stray off the the one there. So now B, C9, B, C9, A, F, O, B, E, B, E3, and then D, B, D, 3, 4, yeah, that's my 4 there. And now E, D, O, E, D, O, F, A, E, D, O, F, A, 9, C, B, 6, 1, 8, 7, 2, 1, 4, 3, 17, 15. Hey, yeah, it's pretty close to an alignment. My god. Right, now D, E, F, D, E, F, 9, A, B, C, A, B, C, 5, 6. Nope, I think the 6 there, okay. To the O, F, that's E, D, E, D, C, B, A, 9, 8, 9, 8. Before we right. No, 8, 7, 6, 9, 8, 7, so get back up. Right, cool. So, we should, with these, borrow from 8. How many? I'm going to miss 1, 2, 3, 4, 5, 6, 7, 8, 9, 7. 1, 2, 3, 4, 5, 6, 7. Oh, that's F there, so I don't need these. What am I doing with this bit? And that should be F, E, D, C, B, A9. F, E, D, C, B, A. Okay, yeah, cool. So I can control B, borrow from there. I did borrow from the correct one and 9. 7, 6, 5, 4, 3, 2, 1. And then this is 5, so I want to borrow from this 5 here. Control V. If on 6, I will do D here. Control V. 3. So it's the C. Copy. Control V. 4. So it's B here. Copy. Control V. 1. To A here. Copy. Control V. 2. So it's A. Copy. Control V. F. So 8 here. So 7. Copy. Control V. Ah, there we go. Back into that. Yeah, so each sort of row and column of these are all the same. If for example, if it starts with a 5, it's always going to be 6, 7, 8, blah 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 blah, and we'll see that everywhere. So we've got 5, 6, 7, 8. Here we have 5, 6, 7, 8. Here again we have where's the 5, 6, 7, 8, and it's the same in every direction. 5, 6, 7, 8. 5, 6, 7, 8, and also down 6, 7, 8. So every row is the same. It just changes its positioning, and that will it will keep like interlacing it as well. So we sort of see that these swap positions, say A and 9 will swap position for this next one, 9 and A, and then these two will also swap position, 9A, A9. So this one will go to here, which was obviously this one went to the top. There, it swapped position, and then here it is again because it swapped 4 times. It went to the top of the 4, and then in the next one it will actually be here in the B's. That's the same as these. It does get a little bit hard to kind of keep track of how many position swaps you've gone through. These will do the same. But luckily, we're not actually going to have to deal with that. Because there's a thing I've noticed. We have A, 9 as the start value, C for the start value. Alright, C. So what we can do now is look here, A, 9, C. So the next one is literally just going to be that B here. And if we look at all those position swaps, there it is. It falls exactly where it should, to the top. And obviously because this starts with B, it's just going to be... did I just copy all that? It's going to be that. So this is going to be the BOO. Ah! And obviously the one that comes after B is C, so we'll grab the C. Control B. B, C, A, so now we need A. Control B. B, C, A9. Oh, wrong one. B, C. Oh, never mind, I was supposed to grab 9, not A. 9, then A. Because we're starting on B. So, where am I? B, C, 9A. I need F now, which is here. F then O. Copy. Paste F. And grab O as well. O. B, C, 9A, F, O. That's C. B, C, 9A, F, O. D, E, 3. D. What did I say? Did I say D, E, 3? Yeah, I did. No, I didn't. E, 3. The positions just keep keep swapping, don't they? 7, 8, 8, 7. Oh yeah, obviously it doesn't swap again, yeah. Yeah, so it does get a bit hard to keep track of it. So up to 3. BC 384 now. Copy. Control paste. B3, 4, grab 1 now, which is here. Copy. 2. Copy. Control V. Oh man. B27. Yeah. Copy. These 8. Copy that. Paste that. 5. And 6. The last one. And this follows all the rules. B to 6, B to 6, and the same everywhere else. So that's how quick it is now to build the next chunk. And we can just do that from all the way from 0, 0, 0 all the way to FFF, and we can build them all out like that simply. Just because now we know the rule of the starting value A, 9, C, etc. There's a potential here that I've made a mistake. Is this A isn't the starting value because it's in the 8th slot. So the potential for this to actually be C isn't all that high. No, sorry, this one is C. Sorry, this one we confirmed. This one might not be B. I've potentially made a bit of a mistake here. So A9. Hang on, I can fix this. This A is the 8th position. So what we can do is we can actually find the 8th position here. So 1, 2, 3, 4, 5, 6, 7, 8. This F. And now we need to find the 8th position that is an A. So this one is an A in the 8th position. And we see 9. Yep. We see C. Yep. A9C. And we do see B. A9C, B. C, B. A9C, B. B, D, O, F. How interesting is that? It does it this way too. Well, that was just lucky. That was just lucky. Oh no. Well, I almost made a massive goof up then. Yeah. Because this is the 8th position. This isn't a starting position. Because it's it's the 8th. The start will be all the way up here. But based on what we've just found out with this A in the start in the 8th position, 1, 2, 3, 4, 5, 6, 7, 8. This 8th, 8, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we found out that this is backwards. So yeah, because it's running backwards through this one. So it's going to be this one here. And we're going to count backwards. 8, 1, 6,
No, what have I done with my brain cells? 1, 2, 3, 4, 5, 6, 7, 8. Oh, as we go down, it runs backwards. Yeah. So if I so this will be our start because where are we? A here. We go down. We go to the next position 9, C, and then now B. So now we want to go up this way. So we would go A7, or if we're on this one, we would just go forwards. A7, 8, 5, 3, blah 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 up to 2. So the first one is going to be a 2. So our our 0, 0, 0 is going to start with that 2 value. And then our, well, let's just grab, no. And then our 1, 0, 0s are going to, yeah, I want to cancel that. We're going to start with that 1, and then our 2, 0, 0s are going to start with 2, 1, 4, and then our 3, 0, 0 is going to start with 3. That's interesting. 4, 0, 0s are going to start with 6. 5, 0, 0 is going to start with 5. 6, 0, 0s are going to start with 8. 7, 0, 0s are going to start with 7. And then lastly, 8, 0, 0s are going to start with 8, which they have. And then the 9s will start with 9. It's quite funny. The A's will start with C, which they have. And the B's will start with B. It's funny that that alternates. I've never paid attention to that before. And then we can go out and build. Well, let's keep going. Let's go into our 900s. No, A, B, C hundreds. And that was 2 to the B to E. It's going to start with E. A, B, C, D hundreds. They're going to start with, well, grab from here now because it's always the same anyway. D. Yeah, D. D starts with D. And then E hundreds. Well, they're not really hundreds anyway, because there's actually 256 possibilities there. Anyway, those. So we did 2 B, E, D. That's O. And then I can already see that O is going to start with F. No, I don't need that many spaces. And that's going to be from 0 all the way down to the F's. So what we're going to see is we're going to see 0 go to 0 FF. And then it's going to go to 2. And that's going to keep going till we get to F. And that's going to go FF. And then what's going to happen after that is it's going to go all the way back to the start. Because there's nowhere else it can go. And this will continue to be our CRC values. Once again, we'll come all the way back up. So after we get down to this one, all the way to the end, we'll have our CRC value.
and then we'll get all the way back up to the 0, zeros, and that 2 will be our CRC value again. And we can just keep filling these out. We can grab the 2 all the way to here, fill that out, fill that out, fill that out, fill that out, and we can just simply keep going like that. So now that we've done that, we should Control A, C, copy that, make sure I've got more than one bloody thing. Now that we've done that, we can go and actually have a look at the lock signals, which is here. So these are the locks from here to here. So I'm just going to grab the count bits so I can see them. Control V. So now I know where that. Now I know we're up to here. Just so I can keep track of what's going on. And I'm going to grab these C values from what's that? 890. Yeah. 884. Yeah, okay, cool. And that's 1 to 13. So just turn that all back into binary bits. 1 to 13. Set it there. Fill that in. Just space all them out. Because it's only going to take no time at all to do this bit. Okay, maybe it took longer than I thought it was going to take. A little wrong digit there. Yeah, once you've worked out which Manchester encoding you have, you know which bit to get rid of. So you can just keep the front bit or the end bit, and you wind up with the encoding anyway. That was zero. So that's 7. That's 8. That's 5. That's 6. That's B. That's C. That's 9. That's A. F. O. D. And E. And 84, 85, 86, 87, 88, 89, 88, AB, AC, D, E, F, 9. Okay, so I'm not missing any there. Good. Now we have to build out these locks. Luckily, it's not going to take the same amount of time as it took us to do the unlocks, because now we know like the rule of it all. So we just have to apply that rule over here, and it will show us how it differs. So first, if I need to work out what place I'm at, This is going to take a bit of brain power, I think. So this is the 4, question mark there, 3, 2, 1. Oops. This off. This was the 4, 3, 2, 1, and that's the 0th. And it is the 8, 0th. So then I'm going to need 1, 2, 3, 4, 5, 6, 7. All question marks there. That doesn't matter. Well, this 7 goes to this 8th position here. Trying to grab another way around what's going on here. And this is a 9. One, two, three, four, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The hell? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Where'd my other value go? Bitch. Oh, I didn't grab it. That's 4. But I've noticed that this is a 9. This is 8F. And this is a 9, 8, 9. So this 4 actually goes up here in the 9th place. And that E is the end. In the 8th place. Alright, yeah, we can do this. So let's drag one over that we can steal from. Drag this one we can nick from. And we want to nick from that one. So I see E in the, what was that 8th place. There's 7. Yeah, because this E right here is 8F, so it's in the 8th place. So 1, 2, 3, 4, 5, 6, 7, 8th place. Find E in the 8th place. And this should be be like this. It's not backwards, is it? It's not going to be backwards, is it? No, that never applied. That never happened in our rule. Let me check here. E is in the 8th place on the B, which is here. We should find another B somewhere, and E should be in the 8th place. 1, 2, 3, 4, 5, 6, 7, 8. In the 8th place on the B. Let's find this B. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's nothing's quick. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. So that's correct. Alright, that's it. So, we know this one is going to be opposite. It's going to be 6. And that's the 80th. So now we need to find for the 800th again of the lots. So now we just need to find the 8th spot that is a 6. So 1, 2, 3, 4, 5, 6, 7, 8, and find a 6 right here. Oh, and then we went backwards when we went up, didn't we? So it should be a 5. So the 900s, no, 700s will be a 5. Where was I? Was it this 6? Was it 1, 2, 3, 4, 5, 6, 7, 8? And then we went. Oh my god, my head. Did we go backwards or forwards? To go up, we went. Yeah, to go down, we went back this way. And to go up, we want to go forward. So it is a 5, and then 8. Can I just grab this? I don't have to think. Now the 600s. It's going to be that 8. Grab the 7. Oh my god, my brain went to mush. Just want to make sure I'm doing this right. So we worked out this was a 6 for the 8s, then 7 for the next one. This is the wrong 7. I want to be here. Why did I grab the... Oh, I grabbed here. One, 2, 3, 4, 5, 6, 7, 8, 6. So I'm grabbing from the wrong spot. Let's just go back a fraction. Start from this side and go down. So 2 starting here. 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, which was this one. And it went backwards 7, 8, 5. Okay. And this one is go up. Okay, so there's something a bit awry here. I'm expecting a low value. It's probably going to start with a low value because the last one did, and this one's ending on an E, so it's a lot of a higher value. If I follow this way, I think I might need to to wrap my brain around what's going on. So this one is a 6. Oh, this isn't. This is not from. I need the one before this. 6, 5, 5. Here it is. Yeah, am I going this way? It says the 4. Yeah. Yeah. No, the 3. Yeah, this wants to go the other way. Oh, because I need to work out which way it's actually going. We can do that. I need to get to a round number after this 8 and then find out what number it is because I know what line we're supposed to be looking at, which is this B line here. No, this 6 line. No, because 6 is in the 8th spot. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8. And we can put 6 in the 8th spot here. So this is the line we need. Then we need to find out which way we need to be travelling on it. So I need to go to, this is 800s. We're already into the 9 and A, aren't we? So we need to find the B. So 6, 8, 9, A, B, or 8, 9, A, B. So it's either going to be a 7 when we get to the B's, or it's going to be or a 9 when we get to the B's. And depending on which one it is going to let us know which way we're supposed to be travelling. That's going to cut out all that confusion. So let's just see where we are. You've got H. And we need to be looking at the ones, so I will have to look at a different button. Interpretation, file, court signal. So I'll go with that 10 as the lock button. My SDR is a bit funny. That's weird. That shouldn't be boot. Get up and try and work out what's going on with the SDR now. The USB is a bit funny. It doesn't like me. And I can't seem to hear my beep boops. I can't use them to know if it's the good beep boop or the not so good beep boop. That should be popping up now. What's going on? Oh, SDR. What are you doing to me, son? Well, now it's just not popping up at all. This is not good. Ah, there we go. Oh, man. Give me my mouse. Just sit over here next to the USB. You can actually not have to get up and move around and piss myself off every 5 seconds. Need to find those, Hey, where are you? Let's grab 3, 4, 5, 6, 7, 8, 9. Let's grab 10. Save. Save. Yeah. Okay, we should be able to work something out right here. $750. Analysis. Let's just flick all of these off and just look at this last one.
just and eight. And it counts. Why is it an 8? That must have been a funny one. It's in the A's still.
Can we use that to know where we're supposed to be up to?
A3D. Eights. Oh, what's my brain doing? B, C, D, F, G, yeah, that makes sense. So we can use the A's to work out where we're supposed to be. But how did we extrapolate backwards before to the AOs? We found that array. So this is A3D. So let's find out what the thing is for that. Let's do it back in. So there was supposed to be somewhere there. And this was the and it is how do I go about finding the place for this one? What we did in the last moment ago. I only got lucky because I had an F. Well, by the count works, it's AD3, which is 7. These are the O's. This is the 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. A, B, C, D. That's really good. Here. So we're looking at about here. Well, that's a 7. which is the same as my value. 3. But it needs to be in the 3. Yeah, fuck. Is it really? Are we? No. 1, 2, 3. This one. That's where we are. Which is... What's this? AD3. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D. Oh, no. 0, 1, 2, 3. Oh, hang on. The D needs to be running this way. No, the D needs to be running this way, and the 3 down this way, which is correct. So this should be D. What should this be? Which way is this? This is our 3. And this should be D. The D position. So that would be E, B, C, D, E. That would be D, B, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0th. D, E, F. And that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What have I done? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, D, 0, 1, 2, 3. So when we do get to A, or 0, 1, 2, 3, I need to just trying to work out how I have these mapped out in my head, and I think this might be backwards. Alright, so we know the CRC for A3D or A D3, because I'm doing it reverse, is this 7. Because the CRC for yeah, because I'm running down. So for example, go back to our 800s. This is 800, 801, 802, 803, 804. This is 800. So I shouldn't really be saying hundreds because that's not how it works. So it's 801, 802, 80F, 810, 812, 813, 814. So that's how I'm doing that. We've discovered that this 7 is the CRC for this A. I'm actually putting a D here for that. AD3. No, I'm not. It's A3D. Because I'm putting the A first. So it's A3D. D. 7. Correct! Correct! No. So now I just need to work out what goes here. And these are the... Oh, here we go, here we go, here we go, here we go, here we go. The A. Yes! Yes, 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 yes. Right. We're cooking now. So now if I can work out what this 1As are, we can look in this from 8 to A and see what direction we're travelling. Right. Now we're getting somewhere. Oh my god. Because I'm a little bit perplexed that it seems to be going upwards. I would expect a lower CRC value to start. Just like with the original, it started at 2. I mean, it could be backwards. Could start at F or E or whatever it was, but I really want to double check it. It's got me a bit confused. I want to double check what's going on. Right, so from here we should be able to map these the rest of the way out, shouldn't we? Because the rule is always the same, so I just need a 6 in the last bottom position here. That's ends with an 8. It is a 9. So I need this right here for the top. Copy. Control V. And that's it. That's the one. Because that 9 is going to come down to a 6, so we'll find a 9. It'll come down to a 6 in that position, which it has. 9. Awesome. Right. So we're at the 8s. Is everything 1 900s? The lock 9. And this is the lock A. And so the 8 is 6. We know the A is going to be a 9. That's a 0. We know it's going to be a 9. So we just work that out. So we need to find, we know this is a 6, this is a 9, we have a C. That is not good. Surely 8 is a 6. Yeah. Hmm. This is this got me a bit confused here. Alright. What was it 7? What's 7? I found the correct place. I think this might be wrong. I think I've grabbed the wrong one. I think I should be grabbing this B line here. I think I need to be grabbing this one. It should actually be a B. That's not right. Alright, so we know that this 6 is the end about here, so we need to find one with a 6 in it here. It really is this 9 line here. Because that would put the 6, and then the 7, and then the 8. So it can't be anything but the 9. And this has... the 8th position is 6. And the 9th will be B. And then yes, C. And it's not a C, we know it's a 9. That's not answered our question at all. The only other explanation, I didn't decode this properly. This reckons it's a 6 too, but it could be one of the instances where it's correct. But we picked out a 7, so it would be plus 1, 7. That's likely to be wrong. 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 Right. Okay, let's shit. Maybe we can work backwards. think it's 9. Well, this is confirmed. It's the A is a 9, right? We know the 8's a 6. So, hey, did I put that in the wrong spot? And that's why this is happening. What did we say that 4 was? Did we write that down anywhere? Jason. Oh. This is data we didn't make up. We actually have this. So let's go 8. 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, 8, 8, 0. Oh, 8, 9, 0. There's 5.2. Yeah, it is 4. The annoying thing is, I actually know the answer. I just can't show it. That this C that we're seeing here is not making any sense. Okay, what else isn't making sense? That's it, that's the only thing that's not making sense. Because if this is the 8th position, hold the phone. What is this 4 doing here? This is the 8. Did I say 8? Oh, god damn. No, it's not the 9. It's the 9's position. 4 is in the 8. It's in the 8, 8, 0 position. 8, 9, 0 position. That's correct. This is in fact 6. Maybe I need more convincing evidence. Maybe I need to go to, instead of 3D, I need to go all the way to F or OO and actually go to the B's. To find out what that is. If this is a 9, this could be a C or a B, because this one's the 6. So I've got 2 in between. It's quite bizarre. This is the line I think it is. 1, 2, 3, 4, 5, 6, 7. The 6 is in the 8th position. I'm assuming 5, 8, 7, 2, 3, 4, 7, 2, 1, 4, 3 is the O's. And then I would be expecting the 9s to be B here, and then the A's to be C and not 9, which we worked out here to be 9. Do the ones break this weird number rule? Where everything is the same as the other one? From memory they don't. What if I refer to the cheat sheet? I'm gonna have to refer to the cheat sheet. I've got no options here. I'm gonna have to refer to the cheat sheet. Okay. I think I've got it. I think I'm on it. This is wrong. Now I need to work out how I show that it's wrong. Alright, so I guess how did we decide this E here? Do I still have... I don't have anything. This 8 is wrong. So this is the 13 ones that we grabbed, wasn't it? Which was... Here they are. And the last one here is it 890, which is here. And this one being E, was it? No, this one was E. So this is in the 8th position. 8th position. Eight position. And now we need to find.
You remember me, but I'm Calvin Buck. I don't take any bill bigger than a 20. See that it's so down to earth. None of that Apple Pay garbage. Kids think because they point their phone at my register, I get my money. I bet you did. I remember you, Omani Butler. Oh, yes, I am. Yeah, I used to look at the ladies in the Cosmo. Well, I don't think that was me. Yeah, I know it was you, you little freak.
I'll have to come back to this.
I found the issue. This E was our 8th position. One, two, three, four. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And that was our problem. 1. We started at 0, 1, 2, 3, 4, 5, 6, 7, 8. That's supposed to be E, not this. So, we find that 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and find E. We're supposed to have this one here. Control V. So that jumps over. And that 4 was the 9. That was 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. Because offset ones. So this is also a question mark. And that makes this B here. So the ones are 8. Oh, Jesus Christ, let's get a shit out of me. How do I do that? Yeah, there we go. So, actually B. So now we need to find a B in the 8th position, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it is still this one. So I must have counted 0 properly. 0, 1, 2, 3, 4, 5, 6, 7. When I was doing this, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8. Position. If I'm B, in the A position, and use this line here, which I brought up here to make it easier to find. So we know that this B, we worked out that this was the A's. So this is the 8s and the A's. So 8s are B, A's are 9. So the 9s are C. So to go backwards, the 8s are here, 6, 5. The 500s will be 8. So the starting value. I'm just starting to draw it in there. So let's do 0, 0, 0, 0, 0, 2, 0, 0, 3, 0, 4, 0, 0. 8, 7, 2, 1, 4, 3. Eights of B, the 9s, C. We don't need that anymore. Let's put that on top. So it's 9, C, 10 to A. Well, 10 to 9, which I've already got there. That. So now B, C, what is going on? C, D, E, F. And we have no other A. The B is going to be A, C will be F, and start value D will be O, E will be D, and F will be E. Yeah, perfect. That maps out, so it's 1, 4, 3, 4, 1, 3, 4, 1, 2, 7, 8, 5, 6, B, C, 9A, B, C, 9A, F, O, D, E, F, O, D, E. And that will map out, the same way all these do. So yeah, that's the B's. So these will be, this line will be, this one. Just like that. And these ones go that way now. Question mark ones. No. Okay. And that was also another question. Yep. Perfect. I managed to work out where we were based on these at 9, C9. Is correct. So, yeah, that's it. We can build out the entirety of every single signal literally based off just one of these chunks, and these chunks sort of follow the rules of one of these, each of these rows or columns, and it just sort of builds out and expands out. So from here we can literally just fill all these out, make like a bit of a lookup table, and find out where we are, and then work out what the, and literally just say we're here, just simply look at the next one, and we'll know what CRC value to use. We just keep stepping through the count and going down and appending the CRCs as we go. Then we can swap to the other command over over here and find the corresponding one for that. So this is 8 for the do I have one that's set out? Yeah, I think the 9s I have set out. Do I have a full one? Okay, no I don't, but let's see where we are. Well, let's just use the 8 for example. So 8, let's 8 zeros, 8, 10, 8, 1, 8, 2. So say we want 8, 2, 0. But we want the unlock command as opposed to lock. So that's 0, 2. So it's 8, 2, 0. Go to our locks. Find the 8, 0, 1, 2. That's the 0th, and it's a C in the case of an unlock, and a 9 in the case of a lock. So now we can actually record lock signal and then change the information. We can advance the count, say here, from here to here, change the command, find that corresponding count. Oh, hang on, we can actually find that corresponding count. What do you know? So what's this? This is the 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. And this is 0th, 1, 2, 3, 4. So we'll start here. So 8, 8, 4. We want to go to 8, 8, 5, and we want to change the command. So we read this one. So it's 8, 8, 0, 1, 2, 3, 4, 8, 8, 4. Go here. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4. We want to go 5. Because we're advancing the count, and that's the CRC, that's 6 right there. And if we choose to do another lock, we would just use the 8. Absolute perfection. Yeah, and that's literally how you do it. And then we could go to the next one. Go to 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. We can go to 6, and then well, maybe we want to lock again. So we go to there. And the unlock would be here. The lock would be here. Unlock. Have to go here because we've already used that one up on lock. Unlock. Or lock, sorry, would be here. Then we would lock it. Lock it again. Is this lock or unlock? One's a locks. So unlock is skip. Where are we? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. B, where's the B? 0, 1, 2, 3, 4, 5, 6, 7, 8. B, we want to go to C for the next. So that's our unlock there. Then our lock. B, G, and would be the next one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to go to B for our next command. 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, B, C. I think I've jumped too far ahead. C, B, A. Is this A or B? 0, 1, 2, 3, 4, 5, 6, 7. Oh, well, now I've lost it anyway. Whatever. That's how it would work. You would do this first command here. So that's the lock. We'll fit that. And now we go to the next count to unlock. Now we want to lock. So we use this the count, we have to go to this one. This one we need to go here. Because we use that one. And we'll leave that so we do this one locked again. We're going to unlock, and now we're going to go here. If you want it to unlock again, you just go here, unlock again, unlock again, unlock again, again. You could, and then for the last one we want to lock, we'd go to this one. And then we'd go into these, so we want it to lock again. No, we wouldn't go, we'd go back up. Here. And then to the unlock. We just use that one, so we use that next one there, and then once they're all run out, we go to the next block. And it goes the same for these. So the count always increases. That's the rule. Each button doesn't have its own count, it's a shared count, so every time you press the button, the count will advance. And we can see that in here. If I go to Manchester X, so the weeks up there. Count will always advance regardless of the button. So these are all our ones. We change to a different button number, And as you can see, 890 went to 891 when the button number changed. So the count always advances. So if we really wanted to waste a bunch of time, we could go through and build all these out based on that, based on this rule here. We'll build every single one of them out, but at this point it's completely pointless. But, you can see there's about 256 to 16 by 16 per sort of these chunks when it goes from 0 to 1, which is this here is 8 all the way down to 9. That's 256 different combinations, because these go from 0 to FF, and yeah, jumps to the next one. So there's 16, and there's 16 of those from 0 to F, and that works out to be that 4,096 different codes of what it was. And then we do the other button that is the same, and so that's times by 2, and we get 8,192 possible codes in the protocol. Makes me wonder if it's brute forceable. If there's only 8,000. I mean, if you know the serial number, I suppose you could brute it, but you have to brute the serial number as well, so it would be possible. There's good look at the protocol again. There's what's that? That's 14 times 4. It's 56 bits, so it would just take far too long. Yeah, we've worked out now that this was our serial, this was our button, this is that count stuff, and then there's the CRC. So these are our like for instance that 800. We're using lock command, and we have to find out what our CRC is. So our CRC is our lock commands. These are unlocks, locks. These are our locks. We've got the unlock. And we're 800, so it's A. So our CRC for this is A. B445CC. Oh my god, I hate when it happens. B445CC. OD02 800 A is our key. Serial button count CRC. And the serial is up to the button number. The button is obviously that button number. And the count. And the CRC. Actually, that 8 would be here because the protocol likes to do it backwards. So this would be, I don't know, backspace. Like that. And we might actually have that in here to prove that. Hopefully. No, we don't have that high up. So maybe we do 9 instead. If you want to showcase that. We should make our CRC something else. Make that CRC 9. You can find it here. 900, which is line 125. Yeah, 1001. So that is 9. Let's look here. So yeah, 900, because this set changes after these get to the end, and then it goes to 00, and then that 9 changes. So when I do the count, I just put that to the front, and I decode the count, because then it makes a lot more sense. It would go 9 to the front 01, 9 to the front 02, 9 to the front 03, so yeah, 8 to the front FF, and then it goes 9 00, 901, 902, 903, 904. So when I do the decoding, I just when I pass information in the count, I just put that 9 to the front. Because that's kind of how the count works for this protocol. Now we can work out the CRC for every single one of them. We can just build out our little boxes and refer back to them, or we can make some kind of a lookup table or something in the code that would reference back to the table and then start building it out, and it would just sort of return the result straight away. For of course now we can have an attempt at actually figuring out what calculation is done for the CRC as well, because now we've got every single CRC possibility, so we may as well work out what math is actually happening to work out the CRC, as opposed to what the CRC is just doing. We actually do the math component to it, as opposed to just doing looking at the sort of core security component of it, and try and work out what it was that they were actually trying to do. I do have that written down somewhere, but I don't remember where.
Not on my desktop. Should just be on the desktop. No, it doesn't look to be here. Well, I did have it written down. Well, I had the sort of the math sequence written down, but it appears to be eluding me. I don't know. Well, I suppose I'll go find that, and that can be the next one. I've gone over the that CRC math stuff now, and I've managed to work it out. This was what we had just from before, our CRC value, and then we worked out was 9 here. Where am I? So obviously that's there, that's our count. Now obviously we can just sort of go ahead and build all of these out if we want to, and sort of reference back to them and have some kind of Python code that can sort of spit out the CRCs for us and generate the the waveform and all that, and do it that way. Or we can actually go ahead and work out the CRC ourselves. There's a handful of ways to do that, and I think one way to do it is use like a sort of like a CRC brute forcing sort of thing that goes through and checks through like all the known CRC calculations and applies them to our data that we have, and we can sort of feed it, maybe just the count data and the count data and a button, or maybe all of it, and kind of work out through just really grinding through it and find out which CRC calculation is our one, which isn't exactly what I did, although it's probably is what was done. After I had filled out all of these all of these little squares, and I had every single permutation, every single possibility, I sent that information. I sent it all over to the boys over in Pirates Plunder, and one of them actually pulled an all-nighter and actually cracked, found out what the CRC calculation was. Before that, I just used these tables to generate every single possibility. I was just stepping through each possibility one at a time to unlock the car. I had them all in folders on my Flipper. I've got like all 8,000 sub files on my Flipper, all in folders, all in order, so I can actually step through and go through each and every single one of the codes. Just plug my Flipper in right now. I actually need to show that. Where are you? I want to go here. So here's all the locks and the unlocks. So I can go to unlock. I can go to the very first 0, or you can go to, let's find the one where you're currently on actually. So that's 9. The last value there. I do that first. Or obviously 9. 9. Here. It's 900, so there it is. 00. That's 900.
which is, as you can see here, and that last value right there is the CRC, and that's the very next. That's the one there. And that's the very next code right there, that 9A, which if I go back to our signals, we can see it there, 9A. And that's how I built. Never mind. That's how I built that out, and then I can go to the locks. So, say I want this one, but I want to lock that count 902. It's a lock. So now I just go count 902. There it is. It's also happens to be paid. Which is quite funny, that actually does happen. Every second one is the CRC is the same. It's quite funny when you see this one say B of 901. So, 901 today. So that's how I was doing it for quite some time before the CRC was worked out. And the way it does it is it takes the button number, and it takes the count, and then it does so here's the 9 at the count, and we'll export that with 0, which is the second one right here, and that will give us 9, and that result is XORed with the next 0, which also gives us 9, and then that 9 we XORed with 2 to give us B, and B will get XORed with 11. That's a constant, it's always 11. So once we've gone through these, it throws in we've gone through the count and a button, it will do the result with 11, which is also B, so that gives a result of 0. And then that result will be plus 9. So that would be 0 plus 9 plus 9, which is 9. And if it was higher, so say we're doing something like our result was 20 plus 9, and then the result's like 29 or something, that's more than 4 bits. It does this, it does an 8-bit like that, where the first 4 is 0, the second lot is all 1s, and then if our result, which is 9, sorry, showing our result, which is this 9, and then if both are a 1, that will be we'll get a 1, and if one of them is a 1, it will be a 0, and if both of them are a 0, it will also be a 0. So it's only if both are a 1 will it give us a 1. So in this case, it also worked out to be 9, and that is our result, 9. We come back up here, that's our result, 9. That's how we'll calculate it. It took ages. It took absolute ages to get to here. Well, I had all the data all accumulated. I had my little thing on the flipper, and it was going swell for some time. And I think someone asked me about it, a few weeks later, a couple of months later, and I sent over everything I had done, and they spent all night on it, and come back with the calculation. I was like, oh my god, no way. it's actually over in Protopirate just recently the result the CRC was actually being calculated wrong for count count values above this 600. There was a different calculation being done than the one that had been worked out. I actually had to go and fix that and remove that that if it's 6, do something else. I just had to get rid of that completely. So it does the same thing for all of them. That was the other thing. That was kind of funny one. I think there was something else with it too, but a CRC was coming back as 8 bits when in fact it's a 4-bit CRC. That's actually fixed now to fix that the other week. It was actually taking that high count value, say it's a 6, and then putting the CRC with it, as opposed to just putting the CRC. Yeah, that's it. So we can do the same thing to any other value. So we just take, it's kind of really a coincidence that 9 is the CRC in the count here. We keep getting back 9 every time. It's usually not that simple. Usually the numbers change quite a bit, but we XOR the 9 with this 0, and then the result of that is XORed with this 0. Then the result of that is XORed with this 2. The result of that is then XORed with 11, and then the result of that is then plus 9, and then the result of that gets put into this little thing, which I can't remember what this is called, and that result is the CRC. This brings everything back to only 4 bits. If say hypothetically this was our result, well if we no, not this. Hypothetically this was our result, but then when we would go through it, this is a 0, this is a 1, it would return a 0. So it would still be 9. It's only if they're both 1s does it return a 1. Every other instance it returns a 0. And that's how it gets it back down to just 4 bits, and that result is the CRC. We should add it with this. Say this result here. So not 21 or anything is yeah. Say it's 12. What do I want to say here? It's, I want to emphasize it's decimal. So 0 plus 9 decimal, and then whatever the result is in decimal, you do that. It's binary. I think that caught me out a while ago. I was looking at it as though it was hexadecimal, and I was calculating that back to decimal, and then recalculating the sort of confusing myself. But yeah, if it's like say like 21 or whatever, then you take this binary and then you feed that binary into this little function here, and whatever it returns is the CRC. Like the 21 actually returns 5. Where's the picture now? So we'll see what 21 would return. So it's 5. Yeah, 21 would return 5, yeah. You can see that here. Because that would return all zeros. That would be a 0 with a 1, that would be a 1, 1, 0, 1, 1, 1, and just the 1s come down, so yeah, it would just return 5. Well, back down to 4 bits, return 5. Yeah, so That gets XORed with that. Its result is XORed with this. Its result is XORed with this. That result gets XORed with that static 11. And then that result gets 9 is added, which is also a static. And then that result gets put through this little function, and the remaining the 4 bits that spits out in hexadecimal is the CRC. And we can do that for all of them. We can do that for absolutely all of them. We can pick just a random one and work that out. Is it worth picking a random one to work that out? I don't want to get it wrong. I suppose we could. So B445 C capitals B445 CZ O space O T O. We use button number 2 again. We'll try to count 5, 6, 7, and I see as unknown. So that was what? 5, 6, 7, so that becomes 7, 5, 6. This is our 2. And now we XOR 7, 0, 1, 2, 3, with 5, 0, 1, 0, 1. The result is 2. That 2 is then XOR with 6. So that's 6. 4. That result is XOR with our 2. Which is that is XOR with 11, which is 1, 0, 1, 1. That's 1, 1, 0, 1. And that gets added with 9, so that's 11 plus 9, which makes that's equals 11 plus 9 equals, what's that, 20? 20 in binary. So decimal 20 in binary. Is this, and we do that thing to it. That works out to be 4. And that should be our result. Right, so let's check that. So we're guessing our result is 4. Or I'm guessing we're doing that, though, we did it correctly. So open up Q4 again. So we're using button 2, which is unlock. Count 7. 5, 6. So we're looking 5s. 4, 5, 6. And the CIC there is 6, so I did something wrong. Let's have another look then. 7. That's 5. Get that result of 2 is then x equals 6. The result of 4 is then x equals 2 is the result of 6. Then x equals 11 gives us the 11 plus, no, that's XOR with 11, that's 20 more zeros, which is 11 plus 9, which comes back as 9. Damn it. Here's my cheat sheet. That was all exactly. Six it's all that more. That's 4. And it's excellent. We got 2. That was all. It's excellent. Where is it? 11. Gives us, no, it gives us not 11, but 11 is. That's plus 12, that's 13, plus 9. And 2. Is this in binary? Ah, there he is, which is 6. There we go. Awesome. We got it. I was just doing some things that were wrong. There we go, which is 6. Which is what is this right here? The B44, whatever, blah, so get back here. 2, 2, 5, 6, 7, 5, 6, 7, DRC, 6. There it is. Heck yeah. That's basically that's the entire thing. I'll probably show this is really obnoxious. Unplug the SDR. Probably show the this system here against the car, maybe in another
video or something, or do a short or something of it, so you can actually see it work. But yeah, I generated it. What's cool is once I'm in the last folder, it's actually in order. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And then once I'm done, I come back and I go down to the 6s, and I can continue through. And then once I get all the way down here, I can go back and down to the next folder and do the same thing in each of the folders. And then once I get all the way down to the end on this F, and down to the end here, on this very last signal all the way at the bottom, I can go back, all the way out, not too far, and go to 0, and start all over again. There it is, there's that too, that we found for the, is that this one? No, that was this one. There it is, 0, so I see starting was 2. There it is, 2. Fantastic. Right, so there we go, that's how it's worked out. Just like that. Give us, put that result there. This result of 6. Which is the CRC. CRC. What's the caption of CRC equals 6. Equals 6. There we go. Oh my god. Alright, now, before I be honest, is there anything else I want to add? Anything else I want to point out or do? Or show? Yeah. In the next one, I'll show how I, yeah, in the next one, what we should do is we should go over all this. So I'll record a signal on the SDR, we'll have a look at it, and then, for example, say the signal is this one, so I'll just take this, copy, paste, and then I'll count, which was about 5, 6, 7, and put that 7 to the front, and we'll generate the next count, 7. I'll work out the CRC for that, and then we'll go ahead and make that into a .sub file, and then we'll TX that to the card and see what it does. Better yet, we may even find a lock signal, so not only will we do this, but we'll change lock to unlock, do the whole thing, find the CRC, make a .sub file, transmit that to the card, and see what happens. That would be a good idea to sort of showcase the that whole process. Awesome. Alright, I will catch you on the flip. I've got plans to make probably a couple of other videos as well. I think I want to touch a little bit on bad USB, a little bit, because it's just a handful. I see a lot of questions around, so people asking how I even go about writing them. I've never really seen much about how you actually go about writing them, where you find the information that you're looking for. So I sort of try and go through that a little bit as well, so that way anyone wanting to know how to even start there will have a good reference point to begin. Might be a couple of other things that would be useful for me to go over as well. Might do something like my top 10 gigs or something, like the apps that I use every day or something like that, so go over them. You always see the questions on what do you do with your flipper, you know? When you everyday carry it, like, what do you do with it? I think that question's asked a ton, so why not answer that in video form as well? Was there anything else I wanted to go over with this? Was that it? Yeah, that was it. I guess the next thing we can do is showcase it, which we got to do, yeah. Alright, awesome. I will see you guys in the future. In the future one, most likely. And it will hopefully be significantly shorter. Alright, so it is.
I literally just found out how to get URH to see the last value correctly. So that way we don't have to do it all by hand with that last that CRC value, because it wasn't seeing the wasn't seeing that last zero, and we had to put it in there ourselves. I literally just found out how to fix it, and it's with this little wrench button. You change this from a 1 to a 3, and then it will actually pick off all the zeros. You literally pick up the last, except for this one. This one was the only one that seemed to have completely failed on. But all the rest, you nailed it. I actually added that other zero, and now my CRC values actually auto-code properly now. These are all correct, every single one of them, except for the one that it missed. And I know it missed it because it says 8, 8 here. These are all A's. We've got 8 in the middle of our A's there, so I know it got this one wrong. But I can grab that whole line now and bring it over, paste it in, fix that 8 to whatever it was supposed to be. I did work it out, it's actually supposed to be a 2, and I can see that by its chest. By going back, by finding it, first of all, which is this. So that's in my last recording, and it's the 4th from the back. Go all the way to the last recording. 1, 2, 3 to 4 here. And literally just look at the 1, 2, 3, 4, 5, 6, 7, 8, and just look at the last 8 bits. Make sure that they're quickly. So 1, 2, 3, 4, 5, 6, 7, 8. Grab those bits. Make sure that's 8 bits long. Yep. Make sure the Manchester pairs are correct. They are correct. And yeah, that's a 2. As we can see, that is in fact 2. So we can just fix it straight away. We don't have to worry about that other 8 because we know it's an A anyway. And you can see 9, A, B, so that A is correct. Yeah, that's just supposed to be a A2. So there was only one we had to fix out of the lot. What am I doing? Yes. How bloody cool is that? There's actually missing a few spots in here because when I went away for a day and was using the car, that's I can find that if I just get back to UIH and find it in here, find the gap in the count. Yeah, there's a little bit of a sort of a bonus. What do they call those at the end of the movie? Yeah, the bloopers. After all of that, I could have just done this. Ugh. Right. Yeet yeet. I still have one more thing to tack on that I just worked out. That decoding that we were struggling with at the start, I've actually worked out how to do it properly now. So I can take a file and just use one of our previous ones. So 50. Remember to do that 3, so we don't lose that last bit. Okay. And come over to analysis. And the way I was doing it is I was doing the Manchester. I come over here and grab the 56 bits. 50. 40, 54, 55, 56. You can see it down here, 56. And then I was creating that label, and then I was coming over here and doing a hexadecimal. And then we get our data. Remember this B4 because it's going to be important. This is always studied. It's the start of our serial. So we can use this B4. So I'm just going to get rid of that. And we're going to make our decoding now. Now we've seen with the Manchester 2 encoding we're using this edge trimmer, which is Manchester encoding the data. A low to high is 1, high to low is 0. We want it the other way around, so we'll use this invert that flips a bit. So we can add that to our decoding. So we get the invert, add the decoding. Oh, hang on. Delete. Okay, and we want the invert, edge trim of the invert, and a cut before and after. And we also want we were doing it like 0, 1, 1, 0, 0, doing B as 1, 0, 0, 1, 1, 0, 1, 0 is the full Manchester coded data. It actually just wants the raw, not the raw data, but it wants the decoded data. It doesn't want the Manchester encoded data, it wants the Manchester decoded data, so it just wants B. And it wants the entire byte, so it wants that 4 as well. Now we can save that as our decoding, back out of there. And now when we do come down to here, it actually strips off all that preamble because we cut before. We cut before B4. It aligns everything correctly and we get our data back. Now the next thing we can do is highlight, just highlight our serial, create a label and name that serial. We highlight our button, create a label, call that button. Highlight our count bits or values, call that count. Highlight our CRC as well, create a label, and we have our CRC. And there we go. Now we can see everything a lot more clearly now. We did that 3 things, so we know that these are correct. And when we say record another signal, so I'll just grab this one, throw it in there. So we just recorded another signal. We can put our 750, do our little 3 thing, good, save that, come back over to analysis, and instead of changing the decoding back and forth, you can actually just highlight the ones that you just added and just apply the decoding directly to it. So that's another little trick I just figured out. You can also do things like remove the serial completely by tongue ticking it. if you don't really want to worry about that, or you sort of want it out of the way, and just focus on the good stuff, you can get a button number as well. You don't want to focus on that. You don't want to focus on the CRC. Put that off, and just focus on the count. Get rid of all of it. It's just the CRC. Maybe you just want to look at the button number or just the serial, for whatever reasons. You have them all displayed. Yeah, a lot of people might be like, I don't want to see the whole serial there. I just want to focus on the main chunk of it, and you sort of just untick that off. When we're just dealing with the CRCs, maybe you want to turn them all off, or we just want to deal with the count and the CRC perhaps. There we go. A little bit of a tip there, and because we did that 3 as well, we say all that hassle with that CRC work we had to do. Yeah, that's the little sort of entrail bit I wanted to add on the end there. I wonder how to get that decoding to properly work. Alright, I'll catch you guys on the next one, eh?